Hello everyone. Yesterday, do you know the time class started? Hi, good evening. Am I audible? All good? Okay, just give me 2 more minutes. I'll set up the mic and everything. I know I'm late. I know I'm 3 to 4 minutes late, but just give me a moment, please. Hi guys, your voice is low. Okay, let me check. Good evening, Sunita. How are you? All good? Having fun? Everybody? Hi, Rakshna. Okay, let's go. We'll be covering today vectors, 3D, and the main thing which was demanded is linear programming and the case study problems specifically on the linear programming as well as 3D. Alright, so what is wrong with this pencil? There is something. Okay, so this is our fourth day. Alright, day after tomorrow we have the exam. See, I'll tell you what, I got 97 in my 12th. I'll not lie, I didn't get 100, but I didn't study I prepared this math. I'm really saying this, I prepared this math in just 5 to 6 days. Just NCRT only you have to do. Even now you have time. Cover up maximum things as much as you can. Maths marks, I'm telling you again, reminding you again that they are going to matter in life. Sir, your voice is low. Rakshna, is it still low? I just reset everything. I've just now, hello. Yeah, it should be correct. Should be fine with it. Okay. Is it still low? Okay, I'll try to speak a bit louder. Will that be okay? Actually, the problem is that one more lecture is going on in the nearby studio. I could not get my own studio today, like the studio which I usually take to take the classes. That's why I've decreased the catching volume a little bit. Okay, I'll keep the mic here so that the voice stays better. Now it's all right. Thank you. All right, Rakshna. Vector we'll start with. Vector is going to be used in 3D, and LPP is a different thing, but very simple thing. Okay, specific type of problem, specific things. Case studies also I'll tell you. If case study comes, case study for linear programming comes, I will tell you that please attempt linear programming case study. That is going to be easier and correct. One more thing I'll remind for all the 2026 aspirants, there are batches going to start. The Nimbus batch for class 11 student, if you are in class 11th right now, the Nimbus batch is for you. Or for droppers, if you are dropping, then if you are planning to drop, then this batch, Phoenix batch, is for you. And the Nexus batch is for class 12 students. Even if you join the class 12 student, this Nexus batch right now as a class 12 student, you'll get a lot of benefit in your second attempt and advance as well. So the price, as I've been telling you, that it is 4499, and this price is going to be valid only till 9th of March. Okay, let's start. This is something, the link and everything is there in your description in the video, below the video you'll see. So you can enroll in these batches. These are really good batches. All the top educators are going to be teaching here. If you want an English batch, then fill the comment box after the video has ended, fill the comment box with the comment that we require in English batch, and yeah, we'll listen to that as well. Vectors, let's carefully read the syllabus of vectors. Vectors and scalars, knowledge of vector and scalar you need to have. Okay, you need to know how to find magnitude and direction, direction cosines, direction ratios of a vector, types of vector, definitions, zero, parallel, collinear and all, position vector of a point, how to find the position vector of a point or negative of a vector, components of vector, very important, projection of vector is very important, addition, multiplication of vector by scalar and scalar product as well as vector product, both are there in your syllabus. Product of vectors, cross product is called vector product and dot product is called scalar product. Position of vector, a point, your syllabus also contains the section formula, definition, geometrical interpretation, all these things are there. Okay, we'll continue seeing them one by one. We'll cover entire chapters. Okay, don't worry, we'll cover entire chapters. If you are sitting in the lecture, if you are solving these questions along with me, you can consider yourself done and dusted for these chapters, and you can be confidently appearing and solving the question in your exam if it comes from these three chapters. Vector, what is a vector? Vector, anything which has magnitude as well as direction, right? Speed, when we are saying a car is running at 50 kilometers per hour, it's speed. A car is running north, in the north direction at 50 kilometers per hour, it got direction also. That means vector just means a quantity which has magnitude as well as direction. For example, force, for example, acceleration, right? These are the vector quantity. In addition to magnitude and direction, two factors. Now, many things are there which have magnitude as well as direction. This question has been asked. Low volume, low sound. No, James, it must be better now. Okay, this has been asked that what is one more. So, MCQ question can be formed that vector is a quantity which has magnitude, direction, magnitude and direction both. And there is one more option, magnitude and direction, and it also follows the parallelogram law of addition. Then you have to mark the third option, which is saying magnitude as well as direction as well as parallelogram law of addition. Okay, the parallelogram law of addition, it has to follow. This is one more thing which is important. It is written in your NCERT that vector is not just the quantity which has magnitude and direction. There are such quantities which have magnitude and direction, but they do not follow the parallelogram law of addition. That means they won't be considered as vectors. All right, let's move ahead. Now, classify the following measures as scalars and vectors. 10 kg, just weight, only weight, not force. This is scalar, only weight. 10 kg in downward direction, force applied. mg is force applied, weight is not that. Okay, 2 meters northeast, 2 meters is the length and northeast is the direction, so this will be vector. 40 degrees alone is a scalar. This is scalar. 40 watt power, tell me vector or scalar? This is completely scalar. 10 to the power 19 coulomb current. Oh, sorry, coulomb is for, this is scalar or vector? Tell me. Coulomb is the unit of which quantity? Charge. Very good. Charge. So charge is scalar or vector? You guys tell me. You are better at physics than me. Charge is scalar or vector quantity? What do you think? Is there direction of charge? It is very good. Very good. It is a scalar quantity. Charge has no direction. Charge is just charge. Current have direction, but charge doesn't. Now 20 meter per second square. That means acceleration. Correct? Acceleration, that means vector quantity. So remember these. Okay, remember this can be asked in an MCQ, very easy MCQ. Now let's understand the types of vectors. Let's go through the definitions. Zero vector. Zero vector means a vector whose magnitude is zero. Direction it can have, right? Magnitude is zero and direction is indeterminate. We cannot, magnitude is zero means there is no length of this vector. So this is just a point. And point's direction, how will you determine? So zero vector has length zero, and if they ask you what is the direction of zero vector, then tell them that direction cannot be determined. It is a indeterminate direction. This is called a zero vector. It is also known as null vector. It is denoted by zero like this and a cap over there. Cap over it. Now, next thing, unit vector. What do we understand by unit vector? Unit vector means whose magnitude is 1. So, suppose if they say this, how do you denote a vector? The vector is denoted like this. Okay, vector is denoted like this. A is a vector, right? Direction over magnitude. Now, if A is a vector and they are saying that A is a unit vector, then by this, what do you understand? That magnitude of this vector is equal to 1. How do you denote the magnitude? By two determinants, mod or determinant, whatever you want to call it. But sound is very low. Beta, I readjusted. Okay, I'll call somebody for sound. Don't worry. I'll call somebody for sound. Okay, I've texted. Okay, try to adjust for a while and the sound will get better. Don't worry about it. I'll try to speak a little bit louder. Now, magnitude should be equal to 1. This is how you can use. All these things we are going to use in the questions. That's why I'm telling you. I promise if you're listening through headset, sound is very low. Sound. Now it must be better. Okay. I'll try to speak like this till the time somebody comes for fixing the sound. Okay. That will be good. I think something is the problem. Alright, free or localized vector. Free or localized vector, that means there is no restriction to choose the origin of vector. You don't have to choose the origin of vector. This is not in your syllabus, but remember this particular definition if they ask it in MCQ. This is not in NCERT, but free or localized vectors means that there is no restriction to choose the initial point of this vector. This type of vectors are called free vectors. When there is a restriction to choose particular point, then it is called a localized vector. That means suppose if you are saying the vector is from A to B, then it is a localized vector. But if we are saying just a position vector is also localized because we are choosing the direction from 0, 0 origin, right? But randomly if we don't choose the initial point of a vector, then it will be called as a free or localized vector. Now co-initial vector, that means two vectors if they are starting from the same point, right? If they are starting from the same point, suppose this is A vector and this is B vector, both of them are co-initial vectors. A, B, AD are co-initial vectors, for example. Reciprocal vector, a vector which has the same direction as A but has magnitude which is reciprocal of A. Suppose A is a vector whose magnitude is 1, whose magnitude is 2, and B is a vector whose magnitude is 1 by 2, but both of them are parallel, are in the same direction. Both of them are parallel. We have to also say that A vector is parallel to B vector. In this case, we can call them reciprocal vectors of each other. Okay, and how do you represent it? A to the power minus 1 like this. Then this will be 1 by A. Same magnitude, but same direction, but magnitudes are reciprocal of each other. Which, for example, which of the following are co-initial vectors? Which of the following over here can we call as co-initial vectors? Come on. Which of the following can we call as co-initial vectors? Co-initial vectors. Two vectors starting from the same point. A, D are co-initial vectors. Look, this vector C is starting from here and vector B is starting from here. So don't think C and B are co-initial. C and B are not co-initial. Both have to start from the same point. So A vector and your D vector are called co-initial vectors. Equal vectors, that means same magnitude. Same magnitude will be called as equal vectors. Can we say that same magnitude vectors will be called as equal vectors? Anybody over here? What do you think? Tell me, what are equal vectors over here? All are equal? No, not all are equal. Not all are equal. Equal vectors means same magnitude and same direction. Remember that. Equal vectors means same magnitude and same direction. Which two vectors are of same length? Vector D and vector B are of same length. So D vector and B vector are equal. Vector A is not equal to C because direction of vector A is this side and C is opposite to it. Okay, direction of vector C is opposite. This is going like this. Okay, and A is going like this. same magnitude and same direction, then they are equal. A and C are D and D and B are equal vectors. Collinear but not equal. Collinear but not equal. We can say A and C are collinear. A and C are collinear, but they are not equal. They are parallel to the same line, but they are not equal. Okay. Collinear means parallel to the same line. Parallel to the same line. They are A and C are collinear. Correct. But they are not equal because their directions are different. Okay. Opposite to each other. Alright. Let's go ahead. Like and unlike. Equal or unequal vectors. Like and unlike or equal or unequal. Say kind of same thing. Vectors are said to be like if they have same direction and unlike if they are opposite direction. Two vectors are like if they have same direction and unlike if they have different direction. Magnitude we are not talking about. We are not talking about magnitude over here. If two vectors have same if two vectors have same direction, they'll be called as like, and if they have opposite direction, they'll be called as unlike. Remember these small definitions. Collinear or parallel vectors. Vectors are said to be collinear or parallel if they have same line of support. Line of support means line parallel to that vector. If both of the vectors are parallel to the same line, then we'll call them collinear vectors. Okay. Line of support means line which is parallel to them. Okay, you'll understand which in the upcoming things. I'll also tell you what do you mean by line of support. The line which is a part of vector. Part of vector means generally how do we represent vector? If you have studied this, then R vector in parametric form is represented like this, lambda time B vectors. Okay, so this is called line of support, which is parallel to this vector. Okay, now let's go ahead. One point. Now understanding. How do we understand the vector? Now, how do we understand the vector? But if there is now vectors we are studying because we are in three-dimensional space now. Till class 11 we were in two-dimensional space. Now we are in three-dimensional space. Three-dimensional space means x-axis, y-axis is there. One more z-axis is there. Z-axis means which is perpendicular to both x and y, which is out of the plane. If this is the plane, then out of the plane we have z-axis. Now, if I want to locate a point in XYZ, that means 3D plane, how will I locate it? How will I locate it? I'll say that this is the point. I'll say, suppose this is the point. This is the point. This is some x, y, z. Okay, x, y, z. Then if I want to address this point, then I'll say that position vector of this A. Position vector of A. Position vector of point A, I'll denote it as A vector. Position vector means with respect to x-axis, y-axis and z-axis, what is the position of this vector? So suppose if this is x, y, z, then I'll just simply write as x I cap plus y j cap plus z k cap. Achha, what are I cap, j cap and k cap over here? I cap, j cap and k cap, simply just understand that these are unit vectors in direction of x-axis, y-axis and z-axis. Right? I, j and k cap are unit vectors parallel to, in direction of or parallel to x, y and z axis. That's it. Any vector you'll represent like this. Okay, any vector you have to represent like this. Let's go ahead. 2 points. If we have 2 points, suppose this is 1 point. Suppose position vector of A I'm writing as x1 I cap plus y1 j cap plus z1 k cap. Okay, and position vector of point B is some x2 I cap plus y2 j cap plus z2 k cap. Suppose like this, I'm defining these two vectors. Then this is point A's position vector, this is point B's position vector. What will be the position vector of AB, line AB? What will be the position vector of line AB? Right, this vector. Then I'll simply do x2 minus x1. If I'm doing AB, then going from A to B, I'm going from A to B. So I'll do x2 minus x1, A to B, this minus this, x2 minus x1, I cap plus y2 minus y1, j cap plus z2 minus z1, k cap, simply. Okay, this is how I'm going to define it. All right, this is how, with questions you will understand these things better. For now it's okay. Let's say for example point A is this, point B is this. So point A's vector will become 1 I cap, 2 j cap, 3 k cap. Position of point B, position vector of point B will become 4 I cap, j cap and 5 k cap. Okay, now they will always give you a free vector. Now this is, its position is not decided, right? It has no starting point. Don't need to worry about free vector. So AB vector will become 4 minus 1, that means 3 I cap, plus 1 minus 2, that means minus 1 j cap, plus 5 minus 3, that means 2 k cap. Simply write like this. Okay, this is how we do. Okay, coming on to, okay, addition of vectors is also very easy. You have to just apply the triangle law. Okay, don't worry about parallelogram law. Parallelogram has two triangles, right? Actually it is parallelogram law which is taught in vectors, but we can also learn it as triangle vector. Now simply listen. Suppose this is some vector A. Okay, this is point A, this is point B, and this is some vector A. Okay, and this is some vector B. Or let's say this is some vector B. Okay, so A plus B, this vector, I am going from here to here. Just understand like this, going from here to here, then from here to here. So what will be the resultant? Resultant will be displacement. Displacement means actually I am going from A to C. So A to C will be nothing but A plus B. Okay, A to C will be nothing but A plus B. First from A, then B. Okay, understand simply like this. Now suppose this direction changes. Now suppose instead of this direction, I tell you that this is coming like this direction. So now this B vector in opposite direction will become minus B. Okay, then you will say A minus B is equal to this vector. Simply. Let's understand with the help of some more questions. Triangle law simply says A plus B. So you are going from here to here, then here to here. So C will be nothing but A plus B. And its magnitude will be square root of magnitude of A plus square root of magnitude of A square plus square root of magnitude of B square plus 2 times of A, B and cos theta. That means angle between them. That means just angle between them. Okay, because to open the magnitude you have to square, right? You have to square. So square of this will become, if I write like this, A plus B and I put a mod and square, then this will become A square plus B square, right? Magnitude only I'll square, plus 2 times A times B. Now this A dot B, later we'll understand that this is a dot product, and dot product means A into B cos of theta. Theta is the angle between these two, right? Right now don't need to worry about it. Okay, let's go ahead, solve some question. Compute the magnitude of the following vectors. Magnitude of A, we'll write like this. Magnitude means this. Now you'll understand everything very clearly. Coming on to questions. Okay, coming on to questions. Magnitude of A, this is how you'll write. Okay, and magnitude just square root of component of I. This is your A vector is I cap plus j cap plus k cap. Okay, and so magnitude of A, which will be written like this, this will become equal to square root of 1 square plus 1 square plus 1 square. What are the components? 1 square plus 1 square plus 1 square. That means root 3 is the magnitude of A vector. Similarly, B vector, what is B vector? 2 I cap minus 7 j cap minus 3 k cap. So its magnitude, that means magnitude of B will become nothing but square root of 2 square plus minus 7 square plus 3 square. Okay, simply just like that. Okay, so this will become square root of 4 plus 49. So here also minus, so minus 3 square, no problem. It will become plus only, plus 9. 49 plus 13. So 62, it will be square root 62. Alright. Similarly, C vector over here is given like this: 1 by root 3 I cap plus 1 by root 3 j cap minus 1 by root 3 k cap. Its magnitude, that means magnitude of C will become nothing but, can you tell me quickly? Can somebody tell me quickly? 1 by root 3 whole square plus minus 1 by root 3 whole square plus minus 1 by root 3 whole square. That means 3 times 1 by 3. That means 1. Its magnitude will be nothing but 1. Root 62. Correct. Very good. Alright. This is how we find the magnitude. I bought all the practice questions that you have. You cannot get anything out of this. Don't worry about it. Find the unit vector in the direction of this vector. How to find the unit vector in direction of a given vector? Unit vector in direction of given vector. How? Unit vector in direction of the given vector. Simply remember this. Unit vector in the direction of any vector will be vector divided by its magnitude. Unit vector, write it down somewhere. Unit vector in the direction of the given vector means vector divided by its magnitude. Okay, one more thing was there. Suppose if two vectors are given equal, 2i cap plus 2j cap is given equal to xi cap plus yj cap. These can be equal only if their components are equal. So say x equal to 2, y equal to 2. Remember this thing also. Right? Remember this thing also. Vector by magnitude. Very good. Very good, Rachna. Very good. Vector divided by its magnitude. Okay. Vector divided by its magnitude. Alright. Find the vector in the direction of this vector which has magnitude 7 units. Second variety in the same question. So this will, for example, this will become 2i cap plus 3j cap plus k cap divided by magnitude of a. What will be magnitude of a? 2 square plus 3 square plus 1 square. Okay. So how much is this becoming? This will become 2 by 4 plus 9 plus 1. 14. Square root 14, right? So square root 14. I cap plus 3 by square root 14. J cap plus k by square root 14. K cap by square root 14. Simple. This will be the unit vector in the direction of this vector. Suppose they tell you find the vector in the direction of this vector which has magnitude of 7. Just multiply this thing by 7. For example, this vector, a unit vector of A will be this vector divided by magnitude of this vector. That means I minus 2j cap divided by square root of 1 square plus square root of minus 2 square, which is 4. So 4 plus 1, 5. That means I cap by root 5 minus 2 j cap by root 5 is your vector in the direct, is your unit vector in the direction of this vector, and you want its magnitude to be 7 units. So multiply it with 7. So this will become 7 by root 5 I cap minus 2 minus 14 by root 5 j cap. This is second variety which can come in the same thing. Very good. 7 by root 5 I cap minus 14 by root 5 j cap. Very good. Alright, let's go ahead. Write the direction ratios of vector, this vector, and hence calculate its direction cosines. They might ask you to calculate the direction ratio and direction cosines also. So how about that? How about that? This is one more variety. Any doubt till now? Direction ratios and direction cosines actually is in 3D, but here I am just telling you how to do this. Right? How to do this. So direction ratios and direction cosines. Okay. Now direction cosines are nothing but this vector's component of I cap divided by magnitude of A. So first we'll find magnitude of A. What will be magnitude of A? Square root of 1 square plus 1 square plus minus 2 whole square. That means 4 plus 1 plus 1. That means 6. So your magnitude comes out to be square root 6. Now direction cosines will be 1 by square root 6. Component of I divided by square root 6. Component of J divided by square root 6. And component of k divided by square root 6, that means minus 2 by square root 6. Very good. Very good. Amazing. Okay, let's go ahead. Find the vector joining these 2 points directed from P to Q. Vector joining these 2 points starting from P to Q. So Q minus P you will have to do. Correct? Remember, starting from P, ending to Q. So what will be the how will be directed? If you are starting from P and ending at Q, then Q minus P you have to do. So minus 1 minus 2 I cap plus minus 2 minus 3 J cap plus minus 4 minus 0 K cap. This is what you are supposed to do. So it will become minus 3 I cap minus 5 J cap minus 4 K cap. Simply, just like this. Okay, just simply this much you have to do. Clear? Section formula. Second part is your section formula. Till now, anything, any doubt, any question which you want to discuss, ask, please tell me. Nothing. Great. Okay. Now section formula. Section formula is also very simple. This vector will be given to you. Position vector of A will be given to you. Position vector of B will be given to you. What you have to do? M. Suppose this point C, position vector of point C's position vector is also given to you. Then position vector of point C will be M times position vector of B plus N times position vector of A divided by M plus N, just like lines. We remember this in lines also. Straight line section formula also we know, right? Similar here also, but here position vectors will be given to you. Suppose your A is given to you something like I cap minus 2 J cap plus K cap. This is your A, right? This is your A vector, let's say. Suppose this is your A vector, let's say. Okay, this is your A vector, and your B vector, let's say, is given to you as I cap 2 I cap minus 3 J cap plus K cap. Okay, now you want to know that what will be the position vector of point C which will divide it in the ratio of 2:1 or 1:1, whatever, 3:2, whatever. So 2 is M and 1 is N. 2 multiplied with B vector, that means 4 I cap minus 3 into 2, that means 6 J cap plus 2 into K, that means 2 K cap plus 2 K cap, right? Plus N into A, that means plus A vector divided by 2 plus 1, 3 will do. Plus A vector you will do. Plus A vector you will do, and divided by 2 plus 1, 3 you do. Externally if it is, then MB minus NA divided by M minus N. This much you have to do. Let's understand these things also with questions. Write two different vectors having same magnitude. Two different vectors but same magnitude. How can the vectors be different if they have same magnitude? How can the vectors be different if they have same magnitude? They can ask you this, or they can ask you this in a MCQ question. They can ask you these type of things in an MCQ question. Two vectors having same magnitude. Okay, just keep the components same. Suppose I am writing I cap minus 3 J cap plus K cap. Okay, so 1, 3 and 1. I should keep 1, 3 and 1. 1, 3 and 1, but components I am making different. Okay, I can write 3 I cap, right? 3 I cap plus, let's say I do minus J cap and plus K cap. Okay, so both of their magnitudes will be 1 square plus 3 square plus 1 square. Simply, here also 3 square plus 1 square plus 1 square. Magnitudes will be same, but directions are different because see, components of I, J, K, N are different. Write two different vectors having same direction. Now you have to write two different vectors having same direction. So ratio of the components should be equal. Suppose I have I cap plus J cap plus K cap. This is my vector. Okay, I want to create a vector which will have different magnitude, but direction will be same. Direction will be same. How will the direction be same? When the components are either equal or they are multiple of some vector. For example, if A vector and B vector are parallel, then A vector will be some lambda times or k times into B vector, where k belongs to any real number, right? K belongs to any real number. Simply that. So if these two vectors are parallel, then A vector will be k times of B vector. So if this is A vector, I'll do 2 times of A vector. That means 2 I cap plus 2 j cap plus 2 k cap. Okay, so ratio 1 by 2, 1 by 2, 1 by 2. If I can do 3, 3, 3 also over here, 4, 4, 4 also, root 2, root 2, root 2 also over here. Any real number I can use over here. Okay, any real number I can use. LPP, PYQs, beta, Joel will be doing after 2 hours, I think. I'm assuming vector 3D might take 2 to 3 hours. All right. So you can come back and revisit if you want to only study LPP. I'll also teach LPP in this lecture. Find the scalar and vector component of the vector with initial point 2, 1 and terminal point minus 5, 7. Initial point 2, 1 and terminal point minus 5, minus 5, 7. Initial point is given, terminal point is given. What will become the vector? Minus 5 minus 2 I cap plus 7 minus 1 j cap, because z coordinate is not given only. So this will be the vector first of all. Now what are the components? Minus 5 minus 2, that means minus 7 I cap plus 6 j cap. This is going to be the vector. Now what are its scalar components? Scalar components are minus 7 and 6. What are the vector components? Vector components are minus 7 I cap and 6 j cap. Right? If you add I cap, sir, will you be able to take area under curve? Yes, I'm planning tomorrow. Right? Or I'm planning that area under curve and differential equations at least, if I can take. With probability, I'll take that. Okay. 7I, so vector component and these are scalar component are minus 7 and 6. What are scalar? Numbers. Minus 7 and 6 are scalar component. Vector component minus 7 I cap and 6 j cap are vector component. Very simple to understand. Okay. Now let's see some more varieties. What all can be asked? Find the unit vector in the direction of this vector. This so you know. A vector divided by its magnitude. A vector divided by its magnitude. Okay. So this will become I cap plus j cap plus 2k cap divided by magnitude of this. That means 1 square plus 1 square plus 2 square. I think we did this question already. Right? Root 6, I by root 6 plus j by root 6 plus 2 by root 6 k cap. Okay, so for the vectors a and b, find the unit vector in the direction of vector a plus b. A plus b you can simply do a plus b, simply just like numbers will do a plus b. 2 I cap, I will be added with I, so 2 minus 1 I cap, it will become 2 I cap minus I cap will become 2 minus 1, j cap minus 1 plus 1, minus 1 plus 1 j cap. So plus minus 1 plus 1 j cap, right? Plus 2 minus 1 k cap. This will become your vector a plus b. That means I cap 0 j cap plus k cap. This is your vector, and unit vector along this direction will be a plus b vector divided by magnitude of a plus b. So what will be the magnitude of a plus b? 1 square plus 1 square under root, that means square root 2. That means our vector will become a cap divided by square root 2 plus b cap divided by square root 2. This is how you will simply write. Take case study. Yes, I'll take case study also, beta. 2-3 case studies I've bought. The diet problem, the transportation problem, right? Those things I've bought. Find the vector in the direction of this which has magnitude 8. So find the unit vector in this direction and multiply it with magnitude 8, right? Multiply it with 8. 5 I cap minus j cap plus 2 k cap. So for example, we have 5 I cap minus j cap plus 2 k cap. Then unit vector in the direction of this vector which has magnitude 8 will become this vector divided by its magnitude. That means 25 plus 1 plus 4, right? This thing multiplied with 8, if you'll do, we'll have a unit vector in the direction of this vector which has magnitude equal to 8. That's it. Very good, Karthik. Very good. Okay, let's go ahead, see more questions. Find the direction cosines of the vector joining these two. So just add these two, right? Joining directions a to b. No, not add these two. Vector joining these 2 points. Direction is a to b. So we'll do b minus a. That means minus 1 minus 1. I cap plus minus 2 j cap plus minus plus 1 minus 3 plus 1 plus 3. Remember, adding subtracting 1 minus 3 it will become, so 1 plus 3 k cap it is going to become. So how much is this becoming? Minus 2 I cap minus 4 j cap plus 4 k cap. Okay sir, minus 4 plus 4 cancel. This is j cap, this is k cap. Don't do that. Some students do that, that's why I'm saying. I'm not saying you would do that. Okay, so find the direction cosines of the vectors. Direction cosine means first find, let's say this is your AB vector. Okay, so first find AB magnitude of AB you'll have to find first. So this will become 2 minus 2 square, that means 4, minus 4 square, that means 16 plus 16. So 32 plus 4, that means 36. This will become 6. Magnitude will come out to be square root 36 is 6. Magnitude will come out to be 6. So now direction cosines is component of I divided by magnitude of AB. That means minus 2 by 6 is the direction cosine. Is one direction, there will be 3 direction cosines. Okay, for x-axis, y-axis, z-axis. This is how you have to find component of I divided by square root divided by magnitude of AB. Similarly, component of J divided by magnitude of AB. Similarly, component of K divided by magnitude of AB. That means square root 6. Okay. Alright, these will be the 3 direction cosines. Show that vector this is equally inclined to OX, OY and OZ. Equally inclined to OX, OY and OZ. Yeah, I have opened 3D or this is vector only. Why are 3D questions coming? Wait, let me see. This is correct only. Maybe some questions of 3D are also there in vectors. Show that the vector this is equally inclined to x-axis, y-axis and z-axis. Actually your direction cosines are what? Cos alpha, cos beta, cos gamma. Right? Now these cos are, this is angle with x-axis. What is this? This is angle it is making with x-axis. This is with y-axis. This is with z-axis. Okay. So if it is equally inclined, it has to make equal angles with x, y and z-axis. What we found over here, these 3 things are cos alpha, cos beta and cos gamma. These are angles value, right? With x-axis, y-axis and z-axis. This is what is the meaning of direction cosines. Okay. Now if they are equally inclined, then their direction cosines should be equal, right? Obviously, we can say over here, what will be the direction cosines? The direction cosines of the vector, vector's direction cosines are what? Component of I, that means 1 divided by magnitude of this vector, 1 square plus 1 square plus 1 square, that means root 3. This is also root 3. That means this is also root 3. So you will say because all the 3 direction cosines are same, that means that this vector is equally inclined to x-axis, y-axis and z-axis. Okay. Now find the position vector of point R which divides the line PQ whose position vector are these respectively in the ratio 2:1 internally and externally. What did we learn? We learned, let's say your vectors are these. Let's say your A vector is this I cap plus 2 j cap minus k cap. Okay, your B vector is this which is minus I cap plus j cap plus k cap. Okay, suppose this is your B vector. Now if it is dividing m ratio n, ratio is what? What is your ratio? Ratio, internal division ratio is 2:1. What is the formula? MA plus NB divided by M plus N. Simply, this is the formula. So M is 2, N is 1. 2 into A, that means 2 times, 2 into B, right? AB is being divided. AB is being divided. 2 into B, it is dividing like this, 2:1. So 2 into B will do, right? Suppose this is the vector, this is your A vector and this is your B vector. Some point is dividing internally. This is 2:1. So 2 into B you will do, correct? 2 into B you will do 2 into, so what will you do? 2 multiplied with minus I cap plus j cap plus k cap. Okay, plus N plus 1 into A you will do, plus I cap plus 2 j cap minus k cap. Okay, divided by m plus n. That means divided by 2 plus 1. That's it. So this will be the position vector. Now 2 I cap minus I cap will become I cap. 2 j cap plus 2 j cap will become plus 4 j cap. 2 k cap minus k cap will become k cap plus k cap. Correct? Divided by 3. Divided by 3. So it is just nothing but I cap by 3 plus 4 j cap by 3 plus k cap by 3. This is the position vector of the vector which divides these two vectors in the ratio 2:1 internally. And if externally we are talking, this is internally, and externally if we are talking, suppose if you want to do externally, this is internally, and externally suppose if you want to do this minus this will be, right? So we'll have 2 I cap plus j cap plus k cap minus I cap plus 2 j cap minus k cap. M into A minus N into B divided by 2 minus 1. Right? Divided by M minus N also we'll have to do this. These are the formulas which I showed you over here, right? M minus N, MB minus NA divided by M minus N. This is what we are doing, nothing else. Divided by M minus N will make it 1, and 2 minus 1 will make it minus 2. This was 2 into minus I it was, right? 2 into minus I it was, no? So minus 2 minus 1, it will make it minus 3 I cap, minus 2 j cap, minus 2 j cap, right? 2 j cap minus 2 j cap, that means 0 j cap. 2 k cap minus k cap, 2 k cap minus k cap or plus k cap plus 3 k cap it will become. Divided by 1. So this will be the position vector of the vector which is dividing these two in the ratio of 2:1 externally, right? Find the position vector of the midpoint. Midpoint, that means ratio is 1:1. So simply just add. This will be 2, 3, 4. This will be 4, 1 minus 2. So this will become, if we write this vector, if I want to write this vector, this will become 2 I cap plus 3 j cap plus 4 k cap. Correct? This will be the vector. What will be this vector? This vector will become 4 I cap plus j cap minus 2 k cap. Okay, simply this is what it is going to become. So you have ratio is 1:1, M is 1, N is 1. So A plus B divided by 1 plus 1, that means A plus B divided by 2. So this plus this 4 I cap plus 2 j cap, that means 6. 2 I cap plus 4 I cap, that means 6 I cap. J cap plus 3 j cap, that means 4 j cap, minus 2 k cap plus 4 k cap, minus 2 plus 4, that means plus 2 k cap, divided by 2. So it will become 3 I cap plus 2 j cap plus k cap. Simple answer. If it is midpoint means dividing in ratio 1, dividing in 1:1. Simply that is going to be the thing. Alright. Now show that the points A, B, C with vectors this and this respectively form a triangle, form the vertices of right angle triangle. Can somebody tell me how will we do this? Form the vertices of right angle triangle. Form the vertices of right angle triangle. But if they are forming the vertices of right angle triangle, suppose they are somewhat like this. Okay, you are going, this is your let's say A vector, this is your B vector, this is in this direction, this is in this direction. Okay, and this is your C vector. Suppose this is your C vector. If they are forming a right angle triangle, then magnitude of A whole square plus magnitude of B whole square will be equal to magnitude of C whole square. Magnitude of A whole square plus magnitude of B whole square will be equal to magnitude of C square. Simple Pythagoras theorem. That's what I'm applying. Right? So we'll find the magnitude. Then we'll see magnitude of A. Magnitude of A will become what? 3 square 9 plus 4 square 16 plus 4 square, that means 16. 32 plus 9 41. Square root 41. Square magnitude of vector B. How much is the magnitude of vector B? Square root of 2 square, that means 4, plus minus 1 square, that means plus 1, plus 1 square, that means 1. How much is this? Square root 6. Okay. Similarly, magnitude of C vector will become how much? Where is the C vector? This is the C vector. Square root of 1 square, that means 1. Square root, plus root minus 3 whole square, that means 9. plus minus 5 whole square, that means 25. 25 plus 9, 34 plus 1, 35, square root 35. And we can clearly see that square root 35 whole square plus square root 6 whole square is equal to square root 41 whole square. Correct? So B and C are these sides actually, and your A will be this side. This is B and this is your C and this is your A. If you want to make a figure, if it is a 3 marks question, make a figure also like this, and the exam checker will be very much impressed already. The moment we have 3 vectors, the concern is collinearity. Okay, 3 points. How to prove collinearity? Collinearity, simply, if 2 vectors are collinear, then it just means they are not same line. Does not mean anything in 3D. Collinear means their direction is same, right? Their direction is same. If A vector is parallel to B vector, then I have to write A vector is equal to some K times B vector. I just have to know this. I just need to know this much, okay, for showing collinearity, nothing else. Okay, if 3 vectors are there which are collinear, then there will be proportional. Their components will be proportional to each other. Just that much you need to know. Let's see this in question. Now, yes, dot product, very important thing. Dot product. Dot product is always scalar. Dot product of 2 vectors. That means A dot B. If there is a dot in between them, then this means magnitude of A multiplied with magnitude of B multiplied with angle between them. So suppose if I am multiplying I cap and I cap, what will be the angle between them? Angle between them will be 0. Both are vectors parallel to x-axis. That means their dot product will become 1. Their dot product will become 1. I dot I will be 1, J dot J cap will be 1, and similarly K cap dot K cap will be also 1. Why? Because angle between them is 0 degree and cos 0 is 1. Cos 0 is 1, and their magnitudes are what? Their magnitudes are 1, 1 only, right? So remember that clearly the angle between a vector A and B is given by this. Remember, angle if you want to find from this one only, what is this? This is equal to A vector dot B vector. So if you want to find the angle, you will just do A dot B divided by magnitude of A multiplied with magnitude of B. And how to do that, I'll show you in the questions. How this is done in the questions, that I'm going to show you very quickly. Okay, so A dot B is equal to B dot A. Some properties, very simple property. A dot B plus C will be A dot B plus A dot C. Simple multiplication. Dot means simple multiplication. Constant is multiplied, you can take out the constant, and you just have to dot the vectors, nothing else. Okay, you just have to dot the vectors. Now, some more points. If A dot B is greater than 0, then angle is acute. No need to remember them, right? Cos theta will be greater than 0, right? Less than 0, no problem with this only. This also, A dot B is equal to 0. That means A and B are perpendicular to each other. Very important point. If the dot product of 2 vectors is coming out to be equal to 0, that means these 2 vectors are perpendicular to each other. Dot product is 0. That means cos 90 only is 0. Cos 90 is 0. Correct? Cos 90 is equal to 0. Perpendicular means 90 degree. If they are perpendicular, their dot product will definitely be equal to 0. Right? A dot A is mod of A square. That means magnitude of A, square of that. Square of A plus B is A square plus B square plus 2A dot B. Here with A dot B, what will this become again? This will again become 2 mod of A dot mod of B cos theta. Right? This is the formula. That is why there this thing was written. Right? In starting, this thing was written. And similarly with 3 also you can do A square plus B square plus C square plus 2AB plus 2BC plus 2C. Right? Simple, just like multiplication we do with numbers. Find the angle between 2 vectors A and B with magnitude root 3 and root 3 and 2 respectively, and they have A dot B. A vector dot B vector is root 6. We simply know, that A dot B, this is nothing but magnitude of A multiplied with magnitude of B and angle between them. So if we want to find the angle, that means cos theta, we'll just have to do A vector dot with B vector divided by magnitude of A and magnitude of B. That means A dot B is given to us root 6. What is magnitude of A and B? Root 3 into 2. That means 2 root 3. Correct. What will this become? Root 2 by 2. right? This will just become root 2 by 2. That means angle between them will be equal to 1 by root 2, right? Angle between them will be, cos theta will be equal to 1 by root 2. That means theta will be equal to 45 degrees. Angle between them is 45 degrees. This is how you have to show. Find the angle between these two vectors. So we'll do the dot product. How to do the dot product? Just write the vectors like this. I cap minus 2j cap plus 3k cap. Just write the vectors like this, right? And this dot with 3i cap minus 2j cap plus k cap. Just write like this. Add, multiply the components. 3i cap into I cap. Suppose if I'm doing like this, 3i cap dot I cap dot I cap. So I cap I just showed you, it will become 1. So you just have to multiply the components, nothing else. J cap will become 1, k cap will become 1. Just multiply the components. 3 multiplied with 1, that means 3 I cap. That means 3 I cap. Okay. This will be 3 I cap minus 2 multiplied with minus 2, that means plus 4 j cap. Oh, sorry. Why am I right? We don't need to write I cap and j cap. 3 multiplied with 1, that means 3. That's it. Minus 2 multiplied with minus 2 plus 4. 3 multiplied with 1 plus 3. That's it. This will be scalar completely. So 4 plus 3, 7 plus 3, 10. Divided by magnitude. Magnitude of A multiplied with magnitude of B. That means, we'll write that separately. So this is the dot product. Magnitude of A, let's say. Magnitude of A will become how much? 1 square plus 4 plus 3 square, that means 9. Right? So this will become 14, square root 14. This will become square root 14. And similarly, for the magnitude of B, what will this become? Square root of 3 square, that means 9, plus square plus 2, minus 2 square, that means 4, plus 1 square, that means 1. So again 14. This is also 14. Okay, this is also 14. So now your cos theta, which is A vector dot with B vector divided by magnitude of A and magnitude of B, this will become, what is the dot product? Dot product is coming out to be 10 divided by magnitude root 14 into root 14, that means equal to 14. So this will become how much? 5 by 7. This will be 5 by 7. Cos theta is equal to 5 by 7. That means theta is equal to cos inverse of 5 by 7. That's it. Cos inverse of 5 by 7. This is how we are supposed to do this. Alright. Okay. Till here, any problem? No problem. Alright. Okay. Geometrical significance of dot product is actually taken for taking projection. If you have studied projectiles or even force in while in the wedge problems, inclined plane problems, what do? We take two components of mg, right? Mg cos theta, mg sin theta. Remember that those components actually are projections of the vector over x-axis and y-axis. Correct? If you understand carefully. Now projection of A for solving questions, simply what you have to do, projection of A on B means A vector dot with unit vector along B. B cap it is. B cap means unit vector along B. B cap means unit vector along B. So if you are taking projection of A on B, A will be multiplied with unit vector along B. And how do we write unit vector along B? How do we write unit vector along B? Over here. Right, unit vector along a given vector will be written by vector divided by its magnitude. Correct? Vector divided by its magnitude. So this complete thing will become what? A vector dot with B vector divided by magnitude of B vector. Correct? Remember like that. If you ratify it, no. If you mug it up, there will be a problem. Just remember projection of A on B means A vector dot with unit vector along B, because we are taking projection on B. If we are taking projection of B on A, then B vector dot with unit vector along A. That means this will become B vector, unit vector along A will be A vector divided by its magnitude. So this will become the formula. This is how you are supposed to be doing it. Now A dot B cap is called the projection vector or unit vector along B. projection vector, you can call it unit vector along B. B cap is called the projection vector, okay, on which you are taking the projection. Find the projection of this vector on this vector. Find the projection of this vector on this vector. Let's say your A vector is I cap plus 3j cap. Is the voice clear? Everything okay? Why did this guy didn't come till now? Let me keep this mic a little bit up. Okay. A vector is I cap plus 3j cap. Now let's say plus 3j cap plus 7k cap. Similarly, my B vector I can write as 7i cap minus j cap plus 8k cap. Okay, what do I want to do? I want to take the projection of this vector on this vector. That means projection of A on B I'm going to take. So I'll take the A vector and dot it with unit vector along B. Now unit vector along B means A vector dot with B vector divided by magnitude of B vector. So simple. So A dot B I'll find A dot B. A dot B I can simply find 1 into 7, 7. 3 into minus 1, minus 3. 7 into 8 plus 56. Plus 7 into plus 8 plus 56. Okay, so this will become 7 minus 3. 4, 4 plus 56, 60. 60 is the dot product. 60 is the dot product. So 60 divided by mod of B. What will be mod of B? What will be mod of B? Come on, calculate and tell me. Calculate and tell me. Magnitude of B. Magnitude of B will be square root of 7 square, that means 49. Plus square root of plus square of minus 1, that means plus 1, plus square root 8, that means 64. So 64, 65 plus 49. Square 114, right? This will become square root 114. So projection of A and B is of length square root of 60 over square root of 114, right? Square root of 114. Great. Let's move ahead. Show that each of the three vectors is a unit vector which are mutually perpendicular to each other. So for mutually perpendicular, the dot product should be equal to 0. Mutually perpendicular means dot product should be equal to 0. Suppose my A vector is this 2. A vector is this 2 by 7 I cap plus 3 by 7 j cap plus 6 by 7 k cap. And this is my B vector, let's say 3 by 7 I cap minus 6 by 7 j cap plus 2 by 7 k cap. What will I do? I'll find vector A dot with vector B. This is what I'll find. Okay, we know this is going to be equal to 2 by 7 into 3 by 7, that means 6 by 7, plus 3 by 7 into minus 6 by 7, that means minus 18 by 7, minus 18 by 7. Now 6 into 2, that means plus 12 by 7. 6 plus 12, 18, 18 minus 18, 0, that means this is coming out to be 0. Now I can simply find B dot C also. You have to write properly. First write these two vectors in dot and then do this. Okay, don't write directly. If it is a 3 mark, 4 marks question also, 3 or 5 mark. Although this can come in 3 marks, this type of question can come in 3 marks. B dot C. Now what is my C vector? C vector is 6 by 7 I cap plus 2 by 7 j cap minus 3 by 7 k cap. This is my C vector. So B dot C, if I want to do B dot C, that means this with this. This means 3 by 7 into 6 by 7. That means 18 by 7. Minus 6 by 7 into 2 by 7. That means minus 12 by 7. Plus 2 by 7 into minus 3 by 7. That means minus 6 by 7. And this is also coming equal to 0. Minus 12 minus 6 minus 18. Minus 18 plus 18, 0. right? This is also coming equal to 0. Similarly, if you will find C dot A, this will also come out to be equal to 0, and then you can say that these three vectors are mutually perpendicular because their dot products are equal to 0. Dot product means A dot B cos theta. Cos theta, theta is 90 degree, cos 90 is 0. That is why dot product definitely will come out to be equal to 0. Evaluate this product. Evaluate the product. These type of questions can come for you, 3 marks. Evaluate this product. So simply multiply like we do. 3A dot with 2A, right? If there is nothing, then you have to assume that it is a dot. Okay, it is a dot. Okay, if there is nothing in between, you have to assume that it is asking about dot product, because there are two types of products in vectors. There are two types of products in vectors, dot product and cross product. So sometimes students think that is it something different or what? Nothing. Okay, 3A cap plus 3 into 7, that means plus 3A vector dot 7B vector, 7B minus 5B into 2A, minus 5B vector dot with 2A vector, correct? Minus 5 into plus 7, so minus 5B vector dot with 7B vector. Okay, A vector dot A vector will become A square. I dot I becomes 1. A is not I, it's not a unit vector, it is a vector, so A square. That means 3 into 2, which is 6. 6 A vector mod of A square. Okay, mod of A square. If they are multiplied, then mod of A square. This is what it will become. Right? Similarly, minus 5 into 7, that means 35 mod of B square. Okay. Okay. Now, 7 into 3 plus 21 A dot B minus 10 A dot B. A dot B and B dot A are equal. So we can write B dot A as A dot B also. 21 minus 10, 11. So it will become 6 mod A square minus 35 mod B square plus 11 A dot B. This is how we'll have to show the computation. Okay, ji. Find the magnitude of two vectors. Next question. Find the magnitude of two vectors A and B having same magnitude and such that the angle between them is 60 degree and their scalar product is 1 by 2. What is scalar product? Dot product of two vectors is called scalar product. Cross product of two vectors is called vector product. So scalar product is 1 by 2. Scalar product is 1 by 2. What does this line mean? This line means that A dot B is equal to 1 by 2. Such that angle between them is 60 degree. What does this mean? Cos theta is equal to 60 degree. What formula have we learned? What formula have we learned? We have learned the formula that cos theta will be equal to A vector dot with B vector divided by magnitude of A vector and B vector multiplied together. So this is given to us. This is given to us. Right? Magnitude of the two vectors A. Find the magnitude of two vectors A and B having the same magnitude. Both of them have the same magnitude also. Both of them have the same magnitude also. Having the same magnitude, that means this will be same. That means this will be same. So now cos theta is given to us. Cos theta nahi, angle between them is 60 degrees. So cos 60 is given to us. This cos 60 is given to us. Right? Cos 60 is given to us, which will be equal to 1 by 2. Right? A dot B is also equal to 1 by 2. A dot B also is given to us, no? Equal to 1 by 2. Correct? So what will we have? This magnitude of A is equal to magnitude of B. This is there. So what we'll do? Magnitude of A multiplied with magnitude of A only we'll do. This will bring this side and this cos theta will take on the other side. A dot B is equal to 1 by 2 and this 1 by 2 will get divided over here. Right? Let me take another page. Okay. Your cos theta is equal to A dot B. That means dot product of two vectors divided by this multiplied with this. Now it is saying A vector and dot with B vector, multiplication of the magnitude. Sorry, it is saying that both of them have equal magnitude. This is equal. So this will become A square only, mod of A square only, magnitude of A whole square only. This thing is 1 by 2. This will become dot product is given to us, scalar product is given to us. That means dot product of two vectors is given to me. Vectors are not equal, their magnitudes are equal, their dot product is also given to me. That means 1 by 2 over here, this is given to me. And these are equal, so what will I do? I'll make them same and write a square over here. Correct? Right? So what will we get? That this a square will come out to be equal to 1. You will take it here and this a square will come out to be equal to 1. Multiply it over here. 1 by 2 cancel. This is equal to 1. Correct? And it is magnitude, so it cannot be negative. So we'll say that my vector A's magnitude is equal to vector B's magnitude and both are equal to 1 simply. Right? Put arrows also over here. In vectors, don't do mistakes in notation. Okay, find x vector if for a unit vector this is the case. Find the vector x if for a unit vector this is the case. X vector, it is saying what will be magnitude of x if x vector minus a vector dot with x vector plus a vector is equal to 12. Sir, can we apply x square minus a square over here? Yes, without any trouble. You can write simply x vector into x vector. I told you, right? A vector dot with a vector will be this square, will be square of magnitude. Right? Because I'll tell you why is this. Because if you understand what is the angle between them, 0. So cos 0 will be equal to a vector dot with a vector divided by magnitude of a multiplied with magnitude of a. Correct? What is cos 0? 1. 1 multiplied with mod a into mod a. That means mod a square, which will be equal to a vector dot a vector. That is why we say x vector into x vector will become x square. So this will be mod of x square minus mod of or magnitude of a square. This will be equal to 12. This is given to you. And this, what is given? For a unit vector A, that means A's magnitude, will be equal to 1. A is a unit vector, that means its magnitude will be equal to 1. So that means what is our equation now? Magnitude of x square minus 1 is equal to 12. 1 square, that means 1 only. That means 13. That means this square is equal to 3. Correct? And will not consider minus root 13 because this is a magnitude, that means positive. So we'll just write this much. Okay? Any problem till here? Nothing so far. Don't forget to like the session if you are there in the session. A vector, B vector, C vector are such that A plus lambda B, it is saying that there is a vector. I'm sure that this might not be very clear to you, so I'm writing once again. This is a vector, this is your a vector, this is your vector A, this is your vector B, minus I cap plus 2 j cap plus k cap. This is your vector B. And what is your vector C? Vector C is 3 I cap plus j cap. And it is saying that these three vectors are such that A plus lambda times B is perpendicular to C. It is saying that A plus lambda times some C vector, this is perpendicular to which vector? C vector. A plus lambda times B. Here we have B. A plus lambda times B is perpendicular to C vector. This is what they are saying. Then find the value of lambda. Okay. A plus lambda times B. Okay. So A plus lambda times B. What we'll do? We'll multiply lambda in B. So it will become lambda I cap minus lambda I cap plus 2 lambda j cap plus lambda k cap. Correct? This is what we'll do. Now we'll do A plus lambda B. So our A plus lambda B, A vector plus lambda B vector will become 2 minus lambda 2 I cap minus lambda I cap. So 2 minus lambda I cap, 2 j cap plus 2 lambda j cap. So 2 plus 2 lambda j cap, 3 k cap plus lambda k cap. That means 3 plus lambda k cap. Okay. And what is our C vector? Now it is saying this vector and C vector are perpendicular. When are two vectors perpendicular? When will you take 3D? Just some more. I think 15-20 minutes maximum. 15. Yes, around 25-30 minutes. Okay. Some 8 to 10 slides are left since till we start 3D. Okay, but for 3D also vector formulas are very important, bache. Okay, now it is saying this vector is perpendicular to vector C. When are two vectors perpendicular? When their dot product is equal to 0. So basically it is saying A plus lambda B, this vector, and dot with C vector, this is equal to 0. Then only two vectors are perpendicular. So what we will find? We will find A vector plus lambda B vector dot with C vector. How do we find dot? Just multiply the components and add the product. 2 minus lambda multiplied with 3. 2 minus lambda multiplied with 3. Okay. Plus J cap is that 2 plus 2 lambda multiplied with 1. Plus 2 plus 2 lambda multiplied with 1. No I cap, no K cap, nothing. K cap is not there in C, so this will be multiplied with 0, so 0 will come. Okay, so they are saying this is equal to 0. So that means 6 minus 3 lambda plus 2 plus 2 lambda is equal to 0. So minus 3 lambda plus 2 lambda minus lambda will go that side. This side will have 6 plus 2, 8. So lambda will come out to be equal to 8. Question solved. Lambda will come out to be equal to 8. Simply solve like that. Okay, we must be clear at this. Let's go ahead. Now A, B, C are unit vectors such that A cap plus B cap plus C cap is equal to 0. Find the value of A dot B, B dot C and C dot A. This question can appear in our exam. Okay, because these are the fundamental questions which we don't do while preparing for competition. Okay, so how will we do this? Simply take dot. Simply take dot. A plus B plus C dot with itself. Dot with itself. That means A plus B plus C. And one important thing, it is saying that A, B, C are unit vectors. If A, B, C are unit vectors, that means their magnitudes. That means their magnitudes are equal to 1. This you will have to mention somewhere. If A, B, C are unit vectors, their magnitudes will be equal to 1. What is this actually? This is your A plus B plus C vector whole square, vector multiplied with itself, whole square. Right? Actually, magnitude of this whole square. Magnitude of this whole square. Correct? Vector multiplied with itself. This is a vector only, no? Vector multiplied with itself. Okay. Now, but I'll show you how to do this. So, what will you do? You'll do A vector, A square, that means A vector into A vector, plus B vector into B vector, plus C vector into C vector, plus 2 times A square plus B square plus C square plus 2AB plus 2BC plus 2CA. We know, right? A plus B plus C whole square is nothing but A square plus B square plus C square plus 2 times AB plus 2 times BC plus 2 times CA. Correct? So this is also same. 2 times AB, that means A vector B plus 2 times BC, B vector dot C vector plus 2 times CA, that means 2 times C vector dot with A vector. Correct? This is given to us. A dot A, that means A square will be equal to 1. This will be equal to 1. This will be equal to 1. A square 1, B square 1, C square 1. Plus 2 times of A dot B plus B dot C plus C dot A. Right? This will be equal to what? What will be the value of this? What will be the value of this? We can find, right? Dot product. If these are unit vectors, what will be the value of dot product? Who can tell me the value of dot product? Come on. What will be the value over here? By this thing is given now. This thing is given. This thing is given to me. Yes or no? So if my A plus B plus C This into this is this square, and this is given equal to 0. So this thing is also equal to 0. No? Correct? This into this I told you, right? Magnitude of this square and this sum is given to me already equal to 0. So this is equal to 0. 0 minus 3 divided by 2. This will become minus 3. Minus 3 by 2 will be the value of this thing which is asked. This 2 will also be divided. Correct? Minus 3 by 2. Very good, Rachna. 0, sir. Very good. Okay. Show that the points A, B, C are collinear. So there are multiple ways of doing it. Actually, find the angles. You can do it by finding the angle. Angle comes out to be 0 in all the 3 cases. They are collinear. A dot B, B dot C and A dot C, if all 3 are equal to 0, then also they are collinear. No. How will you prove? It's in simple terms. How will you prove this? Right, see, if my magnitude, there are 2 ways of doing it. Two simple ways I'm telling you. If my magnitude of AB plus magnitude of BC is equal to magnitude of AC, suppose this comes. Magnitude of AB plus magnitude of BC is equal to magnitude of AC is coming. Then also you can write somewhere that ABC are collinear. This also proves that ABC are collinear. Or either equal or lambda times something, then also they are collinear. Something constant multiplied, then also they are collinear. Otherwise, what we can do, we can simply write their, we can write their vector form. Then also we can say AB minus BC minus CA. That also we can do. Or A plus BC equal to C. AB plus BC equal to CA. Very good, Rachna. Proportional. Ha. Very good. Very good. What we'll do, one more method is there. Actually, I was expecting this. That suppose if you find AB vector. AB vector, if you are finding, what will be AB vector? 2 minus 1. That means 1 I cap. 6 minus 2, that means plus 4 j cap. Plus 3 minus 7, that means minus 4 k cap. Okay. Similarly, BC. What is your BC? BC will become 3 minus 2, that means I cap. 10 minus 6, that means plus 4 j cap. Plus minus 1 minus 3, that means minus 4 k cap. BC is this. And AC, what will become your AC? AC will become what? 3 minus 1, that means 2 I cap. Plus 10 minus 2, that means 8 j cap. Plus minus 1 minus 7, that means minus 8 j cap. Now you see their direction cosines. Direction. This is what? What is your AB? AB is this. Both the ways this is proving. AB is this. BC is this. AB plus BC is giving you lambda times of CA. Right? 2 times. AB plus BC is equal to CA is also. Here you are getting AB plus BC equal to C. Here you are getting AB plus BC. If you will do, you will get CA. Correct? And AC is parallel to BC. Why? Because why is AC parallel to BC? AC is parallel to BC because AC is nothing but 2 times BC. I told you, no. If AC is lambda times some BC, then AC and BC are parallel. You can see AC is parallel to BC. It is parallel. 2 times, 2 times, 2 times. Correct? And similarly, AC is also parallel to AB. AC is also parallel to AB because AC is also 2 times AB. If AC is parallel to BC, AC is parallel to BC and AC is parallel to AB, that means AC, AB and AC are parallel. That means parallel vector means collinear vectors. Collinear vectors. That way also you can say dot equal to 0. But a dot equal to 0, that means perpendicular. Dot equal to 0 to mean perpendicular. Na? How will that make it parallel? Dot equal to 0 will make it perpendicular. Determinant equal to 0. Yes, very good. Area, very good. Area occupied by them. Area of triangle equal to 0, that means determinant equal to 0. That is also one method. Suppose these 3 are vertices of triangle. We'll say that let A, B and C be the vertices of triangle. Area of triangle which you can find. Area of triangle which you find is determinant of these three. That means 1, 2, 3, column wise 2, 6, 10 and 7, 3 minus 1. All three columns, the determinant's value will come out to be equal to 0. Karthikeyan, am I sounding low kya? Have I started sounding low kya? Yeah, bad. Okay, I was coming to that. Okay, if a non-zero vector of magnitude a and lambda a non-zero scalar, then lambda a is unit vector if a is a non-zero vector of magnitude a and lambda is a non-zero scalar, then lambda times a is a unit vector. When it is saying lambda times a is a unit vector, that means lambda times a's magnitude will be equal to 1. Correct? Lambda times a's magnitude will be equal to 1. Lambda will come out because it is constant. Magnitude of a will remain here equal to 1. That means lambda will be equal to 1 by magnitude of a. Simple. This is a question which has, this is in NCERT also and this has appeared in exam also. Similar type, just they changed a vector with b vector. 2020 I think. Yes. Cross product now. Okay. I'll just go and drink water. Small break. Because Rakshana is, no, who said? Karthi is saying, thank you for being so caring. Alright, I'll just be back. All right, let's go ahead. So cross product. Second thing is our cross product. How to find the cross product? Very easy, but we'll just need a determinant solving over here. Okay, nothing else. Yeah, voice is there. Okay. Cross product means, suppose if we had cross product, what does it mean? Now cross scalar product means it will always give you a value. Cross product is going to give you a vector only, right? So that is why cross product is called as vector product. Cross product of A cross B means magnitude of A multiplied with magnitude of B sine theta, and also this is multiplied with a vector which is perpendicular to A cross B. Now whenever you will find cross product of A and B, what the vector which you are going to get will be perpendicular to A and B, A and B both. Suppose this is your A, this is your B, okay, and you are doing A cross B, correct? The resultant which you will get will be perpendicular to both A and B. So if you want, if somebody asks you that you are supposed to find a vector which is perpendicular to both A and B, then that means it is asking you to find the cross product of A and B, because cross product of A and B will always be perpendicular to A and B both, right? So generally cross product was used to study about planes, but planes is neither in the syllabus of CBSE now nor in JEE also. It actually planes of 3D are removed from almost every syllabus except advanced, JEE advanced. There we study about planes. So cross product, just remember that cross product of two vectors will always be perpendicular to both the vectors. This n cap means the vector which is perpendicular to both A and B. Unit vector perpendicular to both A and B, right? But in simple terms, how will we find cross product? Suppose if we have 3i cap plus 2j cap plus k cap, and we are finding its cross product with minus I cap plus j cap plus 3k cap. Suppose we are finding the cross product of these two. What we'll do, we'll just make a simple determinant. We'll write I here, j here, k over here. Okay. Then ax, bx, first vectors components in one row. That means 3, 2 and 1. 3, 2 and 1. And then components of second vector in the last row. That means minus 1, 2, 1 and 3. That's it. And we'll solve this determinant. So how much this determinant will come? We'll solve row wise. First row. So I cap multiplied with 3 into 2 minus 1. That means 6 minus 1. 3 into 2 minus 1. That means 6 minus 1. So 5. Minus j cap. Right? If you have studied determinant, second one will come minus. Right? Minus j cap multiplied with 3 into 3 9 minus 1 into 1. So 9 plus 1 it will become. 9 plus 1, that means 10 it will become. 9 minus minus 1. This product will be minus 1. So it will become 10 over here. Correct? Plus k cap. Again plus minus plus. Just remember like that, even if you have not studied determinants. Right? 3 minus minus 2. That means 3 plus 2. So 5. So what will be A cross B? It will be just 5 I cap minus 10 j cap plus 5 k cap. This will be A cross B. That's it. This will simply be A cross B, and A cross B is important for 3D also. When you have to find the distance between skew lines or parallel lines, then you will need cross product. So that is why remember how to find the cross product. Now let's do some questions on cross product. Find A cross B. If this is A, this is B. Simply what we will do, I, j, k. This is I cap minus 7 j cap plus 7 k cap. So 1 minus 7, 7. This is 3 I cap minus 2 j cap plus 2 k cap. So 3 minus 2, 2. Determinant. I cap multiplied with minus 14 plus 14. So minus 14 plus 14, 0. Minus 7 into 2, minus 7 into 2. So that will be 0. Plus, sorry, minus. Second base will be minus j cap, and this will be 2 minus 21. 2 minus 21, that means 19, minus 19. So it will be minus 19 over here. Right? 2 minus 21. How do you find? You will hide this and then multiply these two. Hide the corresponding row and column. Hide the corresponding row and column and multiply the remaining cross. Correct? Plus k cap. K cap multiplied with minus 2 plus 21. minus 2 plus 21, that means 19. Okay, so it will be 19 j cap plus 19 k cap. 19 j cap plus 19. This will become plus, right? 19 j cap plus 19 k cap will be the vector which is cross product of A and B. Very simple. Okay, 19 j cap plus 19 k cap. This is how you are going to find the cross product. Simple. All right, find the unit vector perpendicular to each of the vector A plus B and A minus B. Now, unit vector perpendicular to both the vector which is perpendicular to A plus B and A minus B will be cross product of A plus B and A minus B. Simple, just that. So A plus B will become 3 plus 1, 4 I cap. So your A plus B will become nothing but 3 plus 1, 4 I cap. Then 2 plus 2, 4 k cap, 4 j cap. Then 2 minus 2, that means 0 k cap. Okay, what will be A minus B? A minus B. So 3 minus 1, that means 2 I cap. Then 2 minus 2, that means 0 j cap. And 2 minus minus 2, that means plus 4 k cap. Now cross product of these two. So I, j, k. Components of I, j and k, 4, 4 and 0. There is no k over here. Here components of I, j, k and 2, 0 and 4. That's it. Okay. And we can simplify this. I cap into 16 minus 0, that means 16. Minus j cap. 16 minus 0, that means 16. 16 j cap. Plus k cap. So 0 minus 6, that means minus 6. So it will become 16 I cap minus 16 j cap minus 6 k cap will be the vector perpendicular to A plus B and A minus B. 8, this is 8 here. 8 minus 0, na, so 8, this will become 8. Minus 8. 16 I cap minus 16 j cap minus 8 k cap. This is going to be the cross product, very simply. A unit vector makes an angle pi by 3 with I, pi by 4 with j and an acute angle theta with k. Then find theta and hence the components of A. Good question this is. In NCERT and in sample papers, both this type of question is there. If a unit vector A makes an angle pi by 3 with I, right? Unit vector, first of all, most important thing over here given is that unit vector A is a unit vector. That means magnitude of A is equal to 1. Okay, what we'll say? We'll say let the vector A be some x, y, z we can take. X I cap plus y j cap plus z k cap. Okay, its magnitude is equal to 1. Its magnitude is equal to 1. Now angle it makes with I. Angle it makes with I. Angle it makes with I, that means direction cosine is pi by 3. What is direction cosine? What are direction cosines? What are direction cosines? Direction cosines means cos alpha is the angle that vector is making with I, right, with x-axis. If it is saying angle pi by 3 with I, that means direction cosines are, we'll write here, it is given that BCs are, or direction cosines are pi by 3, pi by 4 and theta and cos. Okay, this is given to us. Now pi by 3, direction cosine means, how do we find direction cosine? Vector divided by its magnitude. Component divided by magnitude of the vector. Component divided by magnitude of the vector. Correct? So magnitude of the vector is given to us already. Now that means component of x divided by magnitude of the vector is given to us as pi by 3. And component of y, component of j divided by magnitude of the vector is given to us as pi by 4. And similarly, component of z, component of k divided by unit vector is given to us as cos theta, because third angle is cos theta, cos alpha, cos beta, cos gamma, 3 direction cosines are there that we have. Okay, now what we'll do, now we'll use that the magnitude of the vector is equal to, from here what are we getting, x will be equal to, because magnitude of a is given equal to 1, so x will be equal to pi by 3. Similarly, y will be equal to pi by 4. Oh, cos, one mistake, cos, this will be cos pi by 3, no? Angle it is making is pi by 3, so cos pi by 3, and this will be also cos pi by 4, cos pi by 4, correct? So theta will become cos pi by 3, cos 60 degree, right? Cos 60 degree, that means 1 by 2. So x will be equal to 1 by 2 multiplied with 1, that means 1 by 2, correct? Y will come out to be equal to cos pi by 4, that means 1 by root 2 multiplied with 1, that means 1 by root 2. And cos theta, z will be equal to cos theta, z will be equal to cos theta. Now we'll use this thing. Now we know magnitude is 1, that means x square plus y square plus z square, that we imagine it is equal to 1. This magnitude is equal to 1. That means what? What is wrong with this? That means x square we know will be equal to square root of 1 by 2 square, that means 1 by 4, plus 1 by root 2 square, that means 1 by 2, plus cos theta square, cos square theta, this is given to equal to 1. Now we'll be actually solving it and nothing else. Okay, 1 by 4 plus 1 by 2, 3 by 4, right? 3 by 4 plus cos square theta is equal to 1. So 3 by 4 plus cos square theta is equal to 1. Squared both the sides, right? 1 minus 3 by 4, 1 by 4. So cos square theta will be equal to 1 by 4. So cos theta will be equal to plus or minus 1 by 2. Correct? So theta is equal to pi by 3 or pi minus pi by 3. Theta can be both. Theta is equal to pi by 3 or pi minus pi by 3. Alright. Here we can also say that because we have taken theta equal to 1 by 2 and 1 by root 2, you can, if in the options you have, if you have 1 by 2 only, then just mark 1 by 2, not a problem. But this is how you are supposed to solve this question. Important question this is. This can repeat itself in your exams also. Remember, angle it is making with I cap means direction cosine is given to you, DC is given to you, right? Hi Mohammad Niaz, how are you? All good? Sab khairiyat? A cross B is equal to minus of B cross A. Very important. The order matters over here. A cross B is equal to minus of B cross A. Remember that. Cross product is also associative. A cross B plus C is A cross B plus A cross C. Not a problem in that. Constants will come out of cross product also. Okay. Now, suppose if we are taking, listen to me over here. A cross B dot A will be equal to 0. Why? Because I told you, right, A cross B, this vector, the resultant of this vector will be perpendicular to A as well as B both. Now, if we are taking dot of it with A again, now A cross B is perpendicular to A, and dot product of two perpendicular vectors will always be equal to 0. Because A cross B will be perpendicular to A. If A is in the plane, then A cross B will be out of the plane and perpendicular to A as well as perpendicular to B. And if we are taking dot product of two perpendicular vectors, the result will be 0. That is why A cross B dot A will be equal to 0. Small MCQ related things these are. They can ask you these in MCQs. They won't ask you to verify and all, but they can ask you in MCQs. Similarly, A cross B dot with B also will be 0 because A cross B will be perpendicular to A as well as perpendicular to B. So perpendicular vector of B dot with B will make the product equal to 0. Dot product of two perpendicular vectors will be equal to 0, right? This is perpendicular to B, right? This resultant A cross B is perpendicular to B. Are we clear? I cross I, J cross K, J cross J and K cross K will be equal to 0. Why? Why? I cross I. What is the angle between I and I? 0 degree, right? I cross I. What did we learn? That A cross B is nothing but magnitude of A with magnitude of B sine theta, correct? And if theta is 0, sine is 0, sine 0 is 0. So angle between I and I will be 0. So I cross I will become I sine 0. That means 0. So I cross I will be 0. I dot I is 1. J cross J is 0. J dot J is 1. K cross K is 0. K dot K is 1. Correct? I cross J and I cross J will be equal to 1. J cross K will be, I cross J will be equal to K cap. I cross J will be equal to K, because I cross J will be perpendicular to I and J both. What is perpendicular to I and J both? K. J cross K, that means perpendicular to J and K both. What is perpendicular to Y axis as well as Z axis? It's X axis. So J cross K will be I. Similarly, K cross I will be J. Remember these small things, they can ask you in MCQ. These are important for MCQ. These points are made from previous MCQs only. They've been asked. Sometimes students make mistakes in these. Okay. Now, let's look at this question. Find lambda and mu if this cross this is equal to 0. This cross this is equal to 0. That means I cap, J cap. We know one thing only, how to find the cross product. So we'll do that. 2, 6, 27 over here. 1 lambda mu over here. Right? Find this, solve this, and you'll have value of lambda as well as mu. And what do we mean by equal to 0? One more thing is important in this question. What do we mean by equal to 0? Mean by 0, cross product is not scalar. Here cross product is given as a value. Can cross product be a scalar product? Cross product is always a vector product. So this 0 means 0 vector. That means 0 I cap plus 0 J cap plus 0 K cap. Okay, this is going to be important over here. 0 means you solve this and made it equal to 0. Don't do that. Don't do that. This is a common mistake. Scalar product is vector. Cross product is vector. Right? This mistake can happen that you solve this and put it equal to 0, gave a value of lambda. No. Only one variable. Suppose only one variable was there. You solve this and then put it equal to, although when you will solve this, it will come as vector only. So I cap multiplied with 6 mu minus 27 lambda. 6 mu minus 27 lambda. 6 mu minus 27 lambda minus J cap multiplied with 2 mu minus 27. 2 mu minus 27 plus K cap multiplied with 2 lambda minus 6. 2 lambda minus 6. So we can find both the values. This is equal to 0, 0, 0. Compare the components. So 2 lambda minus 6 is equal to 0 and 2 mu minus 27 is equal to 0. From here we get lambda is equal to 3 and from here we get mu is equal to 27 by 2. Okay, both the values you got. And you can see 6 multiplied with 27 by 2. 6 mu minus 27 lambda. That means 6 multiplied with 27 by 2. So 3 into 27 minus 3 into 27. It is also coming equal to 0 only. Alright. It is also coming equal to 0 only. Varsha. Somebody is looking for Varsha. Please respond to King of Tears. Oh my God. What name? How do you guys come up with such names? Amazing, man. Area of parallelogram and area of triangle is also found with the help of cross product. Area of triangle and area of parallelogram also is found with the help of cross product. How? Area of parallelogram is given by determinant of A cross B. I'm sorry, not determinant. Magnitude of A cross B. Sorry for using the term. Parallelogram's area of whose adjacent vertices are A and B. Adjacent sides are A and B. If your parallelogram has adjacent sides A and B, then its area will be given by vector A cross vector B and magnitude of this. And similarly, area of triangle is given by half of area of parallelogram. So half of the magnitude of A cross B. This is how the formula is derived. Formula for triangle area is derived. Okay, remember that. A cross B is the vector area of parallelogram. Okay, vector area. Okay, again, just to remind you, there are 3 batches starting: Nimbus batch, Nexus batch and Phoenix batch. Nimbus batch is for class 11 students. Nexus batch is for 12 students, the students who have just come to 12. And Phoenix batch is for the droppers who are dropping this year and going to appear in 2026 or past 12th, right? So those students can enroll in these batches till 9th March. Why are we reminding you this again and again? Because this offer is only till 9th March. Until 9th March, you can enroll this in for 4,499 rupees, right? 4.5 thousand. That means, and most important thing is that you'll get all DPP, doubt resolution, complete lectures, everything. All the top educators are going to teach in these batches. So do enroll before 9th March. All right. Area of triangle, half of A cross B, half of magnitude of A cross B, half of the magnitude of A cross B. Chai. Area of quadrilaterals also you can find, although this is not in your syllabus. This is not in your syllabus. Just for information, half of determinant of D1 cross D2, where D1 and D2 are the vectors of diagonals. Vectors of diagonals. D1 and D2 are vectors of diagonals. Diagonal vectors. Okay. All right. Given that A dot B is equal to 0 and A cross B is equal to 0, what you can conclude about A and B? If A dot B is equal to 0, that means A and B are perpendicular vectors. If A cross B equal to 0, if A cross B is equal to 0, that means they are parallel vectors. Correct? A dot B is coming equal to 0, that means perpendicular vectors. Correct? If A cross B is coming as 0, means 0 vector. That means these are parallel vectors. Is this possible? That A and B can be perpendicular as well as parallel also. Wow. This is not possible. That means this is not possible. This is not possible. This means A and B both are equal to, both are 0 vectors. Both are 0. This means A and B both are 0 and this means nothing else. Right? A vector and B vector both are 0 vectors. Okay. So this can be asked in MCQ. This thing again can be asked in MCQ. Find the area of triangle with vertices this. Vertices are given. Right? Area of triangle you are supposed to find. So you know the formula actually. But if they can ask you using the cross product, if they ask you specifically, then you have to do, otherwise that's all right. If they ask you by using the cross product, then they can specifically ask you by using the cross product. So you'll simply find AB. First find AB. What will be AB? 2 minus 1, 1. That means 1 I cap. Plus 3 minus 1, 2. That means plus 2 J cap. 5 minus 2, 3 plus 3 K cap. Okay, this is your AB vector. Similarly, you can find BC vector. Right? AB and BC will be adjacent vectors. AB and BC will be adjacent vectors, na? Correct? AB and BC. A to B, then B to C will be adjacent vectors. So find BC only. Don't find CB. Okay, BC will become 1 minus 2, that means minus I cap. 5 minus 3, that means plus 2 J cap. 5 minus 5, that means 0 K cap. Right? That means 0 K cap. So minus I plus 2 J cap. Now what will you do? Area of triangle is given by half of AB cross BC. So you will find AB cross BC. AB cross with BC, right, will be equal to determinant Now AB cross BC, you have to find the cross product. Okay, so you'll write simply I cap, J cap, K cap, and here write the components. First components of AB, that means 1, 2, 3, 1, 2, 3. Then components of BC, that means minus 1, 2 and 0. Minus 1, 2, 0. This much only. Why did I make such a big difference? Okay, this will become I cap multiplied with 0 minus 6, that means minus 6. 0 minus 6. Then minus J cap multiplied with 0 minus minus 3, that means 0 plus 3, so 3. Plus K cap multiplied with 2 plus 2. So 2 plus 2 minus minus 2, that means 2 plus 2, that means 4. So you'll get minus 6 I cap minus 3 J cap plus, wait, how much was this? 2 plus 2, 4 plus 4. This will be AB cross BC. This will be AB cross BC, and area is this, magnitude of half of AB cross BC. So what half of this, that means half multiplied with this, so half of 6, that means minus 3 I cap minus 3 by 2 J cap plus 4 by 2, that means plus 2 K cap. It started hanging already, right? Okay, or you find the magnitude first. You find the magnitude first and then half it. Same thing. Find the magnitude of this. This will become square root of minus 3 square, that means 9, plus minus 3 by 2, that means 9 by 4, plus 2 square, that means 4. Oh, what is happening? Oh. 36 plus 9, 45 plus 16. 61 by 4, square root 61 by 4, square root 61 by 4, square root of 61 by 4. So that means square root 61 divided by 2. This will be our answer. Sir, can we have the last class before evening so that we can revise once? Yes, definitely you can. Yes, definitely. Okay. In fact, I'm planning that if I can come up late night 9 or 10 o'clock with complete revision. You guys put in the comment box what time should I come for complete revision, so that we can revise all the things all at once for the final preparation of the exam. We can do that also, not a problem at all. Okay, let the vectors A and B such that magnitude of A is 3, magnitude of B is root 2 by 3, then A cross B is a unit vector. If angle between A and B is what? A cross B is a unit vector. That means A cross B is a unit vector. This is what it means. What do we know about A cross B? A cross B, we know, sir, this is determinant, magnitude of A multiplied with magnitude of B sine theta. This is given to us equal to 1. And these two values are also given to us. 3 multiplied with root 2 by 3. 3 multiplied with root 2 by 3 is given to me, and sine theta, this is equal to 1. From here, what do I get? I get sine theta is equal to 1 by root 2. This 3 will get cancelled and 1 by root 2. That means theta is equal to 45 degrees. That means pi by 4. Pi by 4 will be a correct answer. This is how you will find in these type of questions. Word problems. They can ask you word problems, or if they want to make a case study on vectors, they'll make it like this, in form of word problem only. They'll elongate a little bit more. For example, a girl walks 4 km towards south, then she walks 3 km in the direction of 30 degree east of north and stops. Determine the girl's displacement from her initial point of departure. Displacement is vector. So you have to find the displacement vector. Sorry, your voice is low. Yeah, now the voice should be okay. Now Okay, I'll try to speak a little bit louder then. Hey, why is voice low, man? Why is voice low? Why? Let me check the OBS. Just a minute. Okay. Now it should sound better actually, but still. Hello. Now it should be better. Okay. Now it should be better. Now it should be better, I hope. Okay. Now, girl walks 4 kilometers towards west, then she walks 3 kilometers in the direction of 30° east of north. Okay. So let's say this is the north, south, this is your east, this is your west. Okay. From here she is starting. She walks 4 kilometers. She walks 4 kilometers in west. So 4 kilometers in west. This is west, 4 kilometers over here. Okay, 3 kilometers. 4 kilometers was the west. Then she walks 3 kilometers in the direction 30° east of north. 30° east of north, if we understand from this, this is our north. From this position, what will be your north? From this position, what will be your north? This position, what will be your north? This will be your north. From this position, this will be our north. Correct? This will be our north, 30° east of north. That means she'll be moving in this direction. This is 30°. So this will be 60°. Right? And for how much she's moving? She's moving 3 kilometers over here. Then what is her displacement from her initial point of departure? She went from here to here, then here to here. So what is this displacement? What is this displacement? Come on, try to solve it. Tell me the vector. Okay. Now, simple thing. See, this direction is negative direction of x-axis. So, let's say this point is A, this point is B, this point is C. Okay. So, AB vector will be negative 4 I cap. Any problem in this? Can I write it like this? Negative 4 I cap. Now it is even near low, sir. Prank call to Kalia. Now it is even. Now it is even low. Why, yaar? Why is the sound making issue today? Okay, let me. How it's not getting some black magic. Switched it off. Must be better now. AB is your minus 4 I cap because it is in negative direction of x-axis and it is exactly parallel to x-axis. So only I cap will come. Only I cap will come. Now BC vector. BC vector will be what? How can you tell me what will be BC vector? Just taking components. BC vector will be 3. BC vector will be your 3 cos 60 and 3 sine 60. That's how you write the vector, no? So BC vector will be written as 3 that is magnitude cos 60 plus 3 sine 60. That's it. Okay. This is going to be your BC vector. So now AC vector will be your AB vector plus BC vector. You know that AC vector from here to here, this displacement will be AB vector plus BC vector. Just do that much. You just have to find AC vector now. Okay. So you'll have minus 4 I cap plus 3 cos 60 I cap, 3 cos 60 I cap and 3 sin 60 J cap. Okay. So I cap 3 cos 60, that means 1 by 2. So 3 by 2 I cap. And sin 60, that means root 3 by 2. Hey, sin 60, yeah, root 3 by 2. So 3 into root 3 by 2 J cap. So plus 3 root 3 by 2 J cap. This will be your displacement. This will be your displacement vector. Right? This will be your displacement vector. Acha, here also you'll have to do something. Minus 4 I cap and 3 by 2 I cap. Both are I cap only. So minus 8 plus 3. That means minus 8 plus 3. That means minus 5 by 2 I cap plus 3 root 3 by 2 J cap. This will be your final displacement vector. Anyway, there is no K cap because she cannot go in 3D. She can walk in plane only. Alright. These type of questions can come as case studies. Sir, is this session enough or do I have to solve NCERT? Beta, all NCERT questions, all examples, all the sample questions also, all the important ones which are not repeated again and again, I have already bought in this session. So, because I know now you don't have any time for solving NCERT or anything, this session should be enough. This session should be enough. All the types of questions I have bought already. Find a vector of magnitude 5 units and parallel to the resultant vector of AB. This you know, resultant vector of AB, that means A plus B. And I'm solving for you guys only. Even repeated questions I'm solving. A plus B, that means 2 plus 2 I cap plus 1 I cap, that means 3 I cap. Plus 3 I cap minus 2 plus 3 J cap minus 2 J cap, that means plus J cap. Plus minus K cap plus K cap, that means 0. Minus K cap is there and here plus K cap is there. So this is the resultant vector of A and B. Now vector of magnitude 5 units parallel to resultant vector. That means vector in the direction of this vector. You need to just find a vector in the direction of this vector, and we have learned how to do that. So that will be this vector divided by magnitude of this vector. And if it should be of 5 units, then just multiply this thing with 5. So that will be 5 multiplied with 3 I cap plus J cap divided by square root of 9 plus 1 square, that is 1. Right? That will be the magnitude. So it will be 5 times 3 I cap by root 10 plus J cap by root 10. So it will be 15 I cap by root 10 plus 5 J cap by root 10. This will be your answer. Right, you'll have to multiply 5. Plus minus 5 actually you should multiply because parallel it is written. So it can be in both the directions. In this direction also, in opposite direction also. So just add plus minus over here for this answer to be entirely perfect. Right? Don't write this part actually. Just write plus minus 5. Why? Because I'm saying in the direction of this vector. If we want to find a vector in the direction of this vector, if I want to find a vector which is in direction of A vector, that will be A vector divided by magnitude of A. Correct? Sir, can you please explain it again? I can't understand this thing. This one, bache? Rakshana, quickly tell me this one. Rakshana, quickly tell me, are you talking about this one or the any other question? Previous. This one. beta BC vector I want to find. If you want to find, if this, suppose if there is a vector, this is the vector, okay, if this is the vector, right? So how do you write this vector? How do you write this vector? You find component with x and y axis, no? Then only I cap and j cap comes. Then only your I cap and j cap comes. Now here it's starting from B to C. It's not starting from origin. It is starting from B to C. It is local. It is not a localized vector. Now it is starting from B to C. So BC's length is 3 units. Correct? BC's length is 3 units. Correct? Now if you want to write the vector, and this vector is making 60 degree with x-axis. This is making 60 degree with x-axis. Okay. So cos alpha will be equal to sine of 90 minus alpha. Correct? So sine of 90 minus 30, that means again sine 60 na. Sine of 90 minus 30. What do we find? Direction cosines are multiplied. Direction cosines only are multiplied in these directions. So 3 magnitude and then multiplied with its direction cosine, and unit vector is I cap. So direction cosine will become what? Cos of 60 will be the direction cosine in the direction of x-axis. And in the direction of y-axis, cos of 30, that means sine of 60. Cos of 30, that means sine of 60 again. So that's why plus 3 sine 60. That's this only I did. So your BC vector will be written like this, in direction of x-axis, in direction of y-axis. This will be the vector, right? This is BC vector. Now AB, it is saying that this girl went from A to B, then B to C, and we had to find the displacement. Correct? Correct? And we have to find the displacement. Displacement will be AB plus BC. AB vector plus BC vector. AB vector is in direction of x-axis only. We are assuming that east-west is x-axis, north-south is y-axis. So this is in direction of x-axis but negative direction. This would be positive, this would be negative. So negative 4 I cap. And this vector will become 3 cos 60 I cap plus 3 sin 60 j cap. This is how you write a vector. Correct? So now AC will be AB plus BC. That's what we did. AC will be AB plus BC minus 4 I cap plus 3 by 2 I cap plus 3 root 3 j cap. 3 root 3 by 2 j cap. This is the answer. Now better? Okay, great. Let's go. Now 3D geometry. Now we'll start with 3D geometry. 3D geometry you cannot do without vectors. Some knowledge of vectors you need to have. What all do we have in 3D geometry? First of all, we don't have planes. Okay. Direction cosines, direction ratios. We already have done direction cosines and direction ratios of line joining 2 points. Cartesian equation and vector equation, both very important part of line. Skew lines. Skew lines means which are not parallel in the plane. Okay, skew lines means which are not parallel in the 3D plane. Okay, and shortest distance between two lines, also angle between two lines. These things we have to cover in 3D geometry. We should know how to do all these. If any question comes from these parts, then we should be able to do that. Okay, let's start. First thing is, in 3D geometry there is no concept of slope, no slope or anything. Okay, in three dimension we don't talk about slope. We talk about direction cosines and direction ratios. Direction cosines means the angles it is making with x, y and z axis. Now 3 axes are there, x, y and z axis. 3 axes are there, not parallel, not intersecting. Very good. So direction cosines and direction ratios are the things that we will define in 3D geometry. We will not talk about slope and all. Let's understand the concept of DC and DR. DRs, direction ratios, simply are the components of I cap, J cap and K cap. Direction cosines are the angles made by these x, y and z axis. For now you can understand this much. Now let's move ahead. Direction cosine, if vector parallel to the given line, if vector, suppose this is your line, right? This is your line, okay, and the vector which is parallel to this line, any vector which is parallel to this line makes alpha degree with x-axis, this is your x-axis, alpha angle with x-axis, beta angle with y-axis, and let's say gamma angle with z-axis. Okay, this is your x-axis, this is your y-axis, this is your z-axis. Now you are talking about this line. If your line, this is your line, you'll assume a vector which is parallel to this line, position vector which is parallel to this line starting from origin. right? Now whatever angle this vector is making with x, y and z axis, those are called your direction cosine. Don't worry, in mathematics understanding theory is always confusing, understanding questions will be easy, but listen to this so that you don't miss out anything in the questions. Okay, direction cosines generally will denote by L, M and N, and direction cosines. Now the cos alpha, cos beta and cos gamma, cos of alpha, cos of beta and cos of gamma will be direction cosines. Cos of alpha is direction cosine of x-axis, cos of beta is direction cosine of y-axis, cos of gamma is direction cosine of z-axis. That's it. Angle it is making with x-axis is alpha, with y-axis is beta and z-axis is gamma. Will denote these by L, M and N. Will denote these by L, M and N. Okay. And one thing you have to remember, that L square plus M square plus N square, the square of cos of alpha, square of cos of beta plus square of cos of gamma will always come out to be equal to 1. Sum of the square of all the three direction cosines will always come out to be equal to 1. This is used a lot of times in the questions, especially in short type questions. Direction ratio, just three numbers proportional to DC. Three numbers which are proportional to ABC are direction ratios. Direction ratios are those three numbers which are proportional to ABC. Suppose if my vector is I cap, J cap, K cap. This is my vector. Then any vector if I make by multiplying it with 2, 3 or 4, suppose 2I cap, 2J cap, 2K cap, or 3I cap, 3J cap, 3K cap, then direction cosines are always proportional. Direction ratios are only proportional to ABC altogether. If we multiply ABC all with 3, then also we'll get direction ratios. So there can be n number of direction ratios. There can be many direction ratios. Whatever is proportional to ABC, that will be the direction ratio. Okay, let's understand with the help of questions and some more things. For example, direction cosine and direction ratio of x-axis are. What is the angle x-axis will make with x-axis? What is the angle that x-axis will make with x-axis? 0 degree. So cos 0. Right. With x-axis, what is the angle x-axis makes with y-axis? So 90 degrees. So cos 90 will be the direction cosine of x-axis. Sorry, y-axis. Direction cosine of x-axis we are writing. No, so x-axis, what angle it makes with x-axis? 0 degree. What angle it makes with y-axis? 90 degree. So cos 90. With z-axis also it will make 90 degree. All the three are mutually perpendicular. Cos 0 is 1, cos 90 is 0, cos 90 is 0. So direction cosines will be these. Now direction ratios will be perpendicular to 1, 0 and 0. That means 2, 0, 0, 5, 0, 0, 6, 0, 0, 7, 0, 0, root 2, 0, 0, anything which is proportional to 1, 0, 0 will be your direction ratios. Now suppose if your vector magnitude is 5, if your vector's magnitude is 5 and direction cosines of vector are 1 by root 2, 1 by root 2 and 0. So what will be your vector? Your vector will be 1 by root 2. You will assume any unit vector which has this direction ratio. Direction ratios means components also. You can understand as components. So any unit vector ABC will be 1 by root 2, minus 1 by root 2 and 0. So 1 by root 2 I cap, let's say, minus 1 by root 2 J cap plus 0 K cap. Okay, this is a unit vector, right? This is one vector. This is one vector whose direction ratios are these. Okay, now what will you do? If you want magnitude of this equal to 5, so you'll divide this by magnitude and multiply it with 5. Divide this by magnitude, then multiply it with 5. That's it, right? This vector in the direction, any vector in the direction of this vector whose magnitude is 5, that will have these direction cosines only. Magnitude of vector should be 5. So what do we do? When we want a vector in the direction of some another vector and magnitude should be something else. So what do we find? We find its unit vector. That means 1 by root 2 I cap minus 1 by root 2 J cap divided by square root of 1 by root 2 plus square root of 1 by root 2. Sorry, square root of 1 by 2 root 2 square plus 1 by root 2 square, that means 1 by 2 plus 1 by 2, that means 1. Right? Here it will come as, right? This is what you will do, no? 1 by root 2 square plus 1 by root 2 square. So that will give you 1 only. 1 by 2 plus 1 by 2, 1, square root of 1, 1. So 1 by root 2 I cap minus 1 by root 2 j cap. This will be your vector. Multiply this with 5. So it will become 5 by root 2 I cap minus 5 by root 2 j cap. Right? This vector will have magnitude of 5 and direction cosines as 1 by root 2 and minus 1 by root 2. Direction cosine and direction ratios of line joining these two. Direction cosines and direction ratios. So this is most important. Third part is most important. Most of the time used. Sir, is vector necessary to understand 3D? Yes, bache. Vector is necessary to understand 3D, but I'll try to tell whatever you require. If you don't understand something, let me know. So now direction cosine and direction ratios of line joining these two. So line joining these two will be 0 minus 1 I cap, 1 minus 2, that means minus 1 j cap, minus 1 k cap. So what is your vector? Minus I cap minus j cap and minus 2 k cap. This is your vector. Now see your direction cosines. How will you find direction cosines? In vectors also we did. DCs will be what? Component of I divided by magnitude of this vector. That means minus 1 divided by 1 square, 2 square. 4 plus 1 is 6. Minus 1 by root 6. Direction cosines will be fixed. Minus 1 by root 6 again. And minus 2 by root 6. These will be direction cosines. Direction ratio will be just proportional to these things. That means minus 1 by root 6, minus 1 by root 6, minus 2 by root 6. Or you can also write like this. Direction ratios are k into minus 1 by root 6, k into minus 1 by root 6, and minus 2k into k into minus 1 by root 6, k into minus 1 by root 6, and k into minus 2 by root 6, where k is any real number. You can write like that also. Tomorrow any session like 100 PYQs. We'll have a revision session. 100 PYQ, beta, there is no point in doing that. There is a lot of change in syllabus every year. From 2021 to 24 also you'll come, no? There is a lot of 225 also if you'll come, no? There is a lot of change. So PYQs I don't recommend doing. Do sample paper solving if you want, that we can do. We can solve 4 or 5 sample papers in revision. No problem in that. But PYQs there is no point right now. Look. Now look at these questions. First complete exercise of NCERT. Complete first exercise of your NCERT. Line making 90 degree, 135 degree, 45 degree with x, y and z axis. Find its direction cosines. So cos 90, cos 135, cos 45 simply. Cos 90, cos 135 and cos 45. So that will give us cos 90, that means 0. Right? Cos 90, that means 0. Cos 135, that means cos 90 plus 45. That means minus sine 45. That means minus 1 by root 2. And cos 45, 1 by root 2. So these will be direction cosines, which are fixed. Find the direction cosines of line which makes equal angles with the coordinate axis. Second, equal angles. So let's say let the angle line makes with coordinate axis be alpha. It is making equal angle. So direction cosines will be cos alpha and cos alpha. And we know sum of the square of direction cosines, that means L square plus M square plus N square plus N square is equal to 1 always. That means 3 cos square alpha will be equal to 1. That means cos square alpha will be equal to 1. That means cos alpha will be equal to 1 by root 3 plus or minus. Okay, cos alpha will be equal to 1 by root 3 plus or minus. Okay, so lines can be can have direction cosines as plus 1 by root 3 or minus 1 by root 3. If a line has direction ratios minus 18, 12 and minus 4, what are the direction cosines? Come on, can you tell me this? Can you solve this for me? Come on, solve this one for me. Direction cosines are given, direction ratios you have to find. Very simple thing. If you have listened carefully so far, you'll easily give the answer for this. But if direction ratios are this, that means line, a simple line will be parallel to this line. All those lines will be parallel to this line. Minus 18 I cap plus 12 j cap minus 4 k cap. Right? They all will be parallel to this vector. The lines will be parallel to this vector. If these are direction ratios, it simply means that that line will be parallel to this vector. And parallel to this vector, these components of the parallel vector only are direction ratios. Components of the parallel vector only are direction ratios. That means direction cosines will be what? Magnitude. The magnitudes will divide. That means minus 18 plus 12 minus 4. Minus 18 plus 12 minus 4. So minus 18 I cap plus 12 j cap minus 4 k cap. This is your, so your DRs given to you are minus 18, 12 and minus 4. So parallel, line will be parallel to, you can say line is parallel to the vector, this vector. Okay, so direction cosines, we know how to find. It will be component of I divided by magnitude of this, divided by 18 square plus 12 square plus 4 square. Correct? Comma 12 component of j divided by magnitude 18 square plus 12 square plus 4 square. Comma minus 4 divided by this magnitude again. Okay. How much will be the square? 144, 396 and 16. 484. 8 plus 8, 16. 16, 6. 364 plus 144 plus 16. 484, correct. Right? So it will become minus 18 by square root 484. Comma 12 by square root 484, comma minus 4 by square root. 484 is also, I think, a complete square. 22 it will be. 2 plus 2 half. 22. So minus 18 by 22, 12 by 22 and minus 4 by 22. Correct? Clear? Over here. These will be the direction cosines. Now find the, now other question. Show that the points are collinear. This we have done in vectors a lot of times. These points are, if you want to show that these points are collinear, we can find the area of triangle. We can show AB plus BC is equals to AC. So many methods are there. Okay. But in 3D, actually, there is one more method. Right? Suppose if we take that, suppose if we assume that the direction cosines of, if we assume the direction cosines of these 3 points, x1, x2, x1, y1, z1, x2, y2, z2 and x3, y3, z3. Let's say if we do like that, and then we find x2 minus x1, y2 minus y1 and z2 minus z1. We'll find that they are all proportional to each other. Okay, for example, 2, 3, 4. For example, I'll do this for you. What are the points? Just a minute. What are the points? 2, 3, 4, minus 1, minus 2, 1. These are the points. No, 2, 3, 4, minus 1, minus 2, and 1. Minus 1, minus 2, and 1 we have. What else? We have 5, 8, 7. We have 5, 8, 7. So we'll assume this as x1, x2, x3. This one as y1, y2, y3. Ari is searching for hero. No, hero is not there right now. He's not there, Eddie. Maybe on another video. Okay. So, so minus, if you take this as A, this as B, this as C. You can do this with vector method also. I think this one question, first exercise of your 3D is entirely about vectors only. Right? There is nothing related to 3D over here, just the names. So you see direction cosines, direction ratios, we have done in vectors also. Find the direction cosines of the sides of triangle whose vertices are these, and these. Direction cosines of sides of triangle whose vertices are these. This one will be different. No problem with it. This one is a little bit different. So you'll have to find AB, BC and CA. I'll show you fifth one. I'll show you how do we do the fifth one. Okay. So what do we have? The points are 3, 5, minus 4, minus 1, 1 and 2. 3, 5, minus 4, minus or. Suppose these three are the vertices of triangle, let's say. Okay. Suppose these three are the vertices of triangle. But in this case, it is saying direction cosines, it is asking you to find. Alright, so we'll use these only. 3, 5, minus 4, minus 1, 1 and 2. 3, 5, minus 4, minus 3, 5, minus 4. Then minus 1, 1 and 2. Minus 1, 1 and 2. And this is, we have minus 5, minus 5, minus 2. Minus 5, minus 5, minus 2. Okay, these are vertices of triangle. What is it asking? Find the direction cosine. Direction cosines we have to find. So AB we will find first. What will be AB? Minus 1, minus 3, that means minus 4 I cap. Minus 1, minus 5, that means minus 4 J cap. 2 minus minus 4, that means plus 6 J cap. Similarly, your BC, what will be BC? What will be the BC line? BC vector or BC line? Minus 5 minus minus 1, that means minus 5 plus 1, that means minus 4 I cap. Minus 5 minus 1, that means minus 6 J cap. Okay, and minus 2 minus 2, that means minus 4 J cap. And then AC also. You can find AC also from here. AC will find, AC vector will become minus 5 minus 3 minus 8 I cap. Minus 5 minus 5, that means minus 10 J cap, and minus 2 minus minus 4, that means minus 2 plus 4, so plus 2 K cap. Now direction cosines over here, minus 4 divided by square root of 4 square plus 6 square, 32 plus 36, 98, so square root 98, comma minus 4, J component, minus 4 divided by square root 98, comma 6 divided by square root 98. No, 32 and 36, so 68, 98 how? 68, square root 68, square root 68, and here also square root 68. Similarly, direction cosine of this side will become minus 4 divided by 4 square, 6 square, same thing. Minus 6 by square root 68, and 6 by, and minus 4 by square root 68. So these will be the direction cosines. Okay, this is how you have to do this one. All right, let's move to second exercise where more important things are there. So there are two forms of writing a straight line. There are two ways or two forms of writing in which we can write a straight line. For example, suppose this is our line. This line I want to write. Okay, I want to write this line. I want to write the equation of this line. By that what I mean, I want to write the equation of this line. Okay, suppose that. Now how will I write? I'll take any one point randomly. Let's say this is my point. Randomly I'll take one point. Let's say x I cap, y j cap plus z k cap. I'll take position vector of this point. I'll take position vector of any point on this line. Okay, and one point will be given to me. One point will be given to me and another I'll assume. Okay, now suppose I want to write the equation of this line. I know that, and I'll be having three things. Okay, when we need to, whenever we write the equation of line in 3D, we have three things. Listen carefully. One, a vector which is parallel to that line, which is this B vector. Vector that is parallel to this line, B vector will be given to us. Another thing, one point will be given to us on the line, which is this A point. Position vector of this point will be given to us on the line, which is this A vector. Okay, and then we have to form the equation of line. What we will do, we'll assume one point on this line. Let's say this point we are assuming, right, this point x I cap plus y j cap plus z k cap. This point we are assuming, and this point is given to us, let's say x1 I cap plus y1 j cap plus z1 k cap. Okay, position vector of this point is given to us. Position vector of this point we have assumed. Now this line will be what? I know that this vector is parallel to this line. That means B is parallel to this line. That means my AR vector is lambda times the B vector. Vector B is parallel to this line. So AR vector is lambda times of this B vector. Definitely. What is AR vector? X minus x1 I cap, y minus y1 j cap, and z minus z1 k cap. Right? This is my vector. But if I don't want to write in these terms, if I just want to write in parametric terms, what can I say? R vector minus A vector. Obviously, by A vector plus R vector, according to this, according to triangle law, A vector plus R vector is equal to, sorry, A vector plus B vector. A vector plus A vector, or wait, let me write like this. Let me take this as AR vector. So A vector plus this AR vector will be equal to R vector. So my AR vector will come out how much? R vector minus A vector, no? That's what is written over here. This AR vector will come out as R vector minus A vector. This is equal to lambda times B. So R vector will be equal to A vector plus lambda times B vector, where R is position vector of general point on a line, any general point. That's what we took, general point on the line, right? A is given point on the line. This will be position vector of given point on the line, and this B is vector parallel to the line, in simple terms. Okay. Now, if you have listened to this, very easily you will be able to write it in Cartesian form. In Cartesian form, you use direction ratio. X minus x1 divided by A, y minus y1 divided by B, z minus z1 divided by C equal to some lambda, where these A, B and C are just direction ratios of the line. X is general point, x1, y1, z1 are given to you. A, B, C are direction ratios of the line, and some of them can be 0 also. Here there is no problem. These can be 0. These can be 0. This is not, we are not defining. These can be 0. These direction ratios can be 0 also. Not a problem in that. Okay. These can be 0 also. Here definition and all does not matter. We'll call them defined only. For example, Cartesian equation of this line we have to write. So we'll assume one point, x I cap plus y j cap plus z k cap. Now what will be the equation? X minus 1 divided by direction ratio of vector parallel to this line, that means divided by 1, equal to y minus 1 divided by direction ratio of j vector parallel to this line, that means 2, equal to z minus 2, that means z plus 2 divided by direction ratio over here, which is 3. This is how you will write the equation of line in Cartesian form. DRs are given over here. Okay, here also DRs are given to you. So if DRs are given, very well, this will become x minus 1 divided by 1 equal to y minus 1 divided by 1 equal to z plus 2 divided by 1. Here direction cosines are given. So what? Divide by direction cosine. Direction ratios are multiples of direction cosines only, no? And equal to some k you can write. Equal to some k you can write. So here also x minus 1 divided by 1 by root 14, y minus 1 divided by 2 by root 14, and z plus 2 divided by 3 by root 14 equal to some k, where k is any real number. Right? Equal to some k where k is any real number. Why are we adding k? Because direction ratios are proportional. Right? Direction ratios occurs proportionally. All right. This is what. Okay. You can, this can be direction cosines also. Direction ratios and direction cosines are proportional things only, So you have taken this only as direction ratio. What's the problem? Not a problem. Just give me a minute. I have to take this call. Yes, sir is there. I hope quality content viewers know you. You are alone with this one will grow. Okay, no problem. Okay, let's move ahead. Equation of x-axis. X by 1. X-axis direction ratio will be 1. So obviously this can be asked. Direction ratio of x-axis only will be equal to 1. So x by 1. X equal to 0, right? Simple thing. Even if you have to guess. X equal to 0. Simple. Alright. Now, direction ratio of x-axis we discussed just now. 1, 0, 0 will be the direction ratio. Find the vector and the Cartesian equation of the line that passes through the point. That passes through these 2 points. Vector equation and Cartesian equation, both the things. Okay, I'll just show you. See, line passes through this point and this point. So A will be this and B will be this. Your R will become what? What will be your R? R will be vector which is parallel to this. That means this vector plus lambda times this vector. So you can take any one of these. Like parallel, your line will be parallel to the AB vector, which is 3 minus this vector minus this vector. That's what you did. So R will become equal to 3 plus this plus lambda times this. Okay. Wait. I'll write then and show you. Let me write this again. Sir, how about 11th standard, sir? Audio is very low, bro. Oh, okay, bro. Thank you for letting me know, bro. Wow. I hope you are not a student. Now it must be better a little bit. Alright. So A vector and B vector are given to you. You will take these two as the vectors only. Line passes through these 2 points. So 3 I cap minus 2 j cap and minus 5 k cap. And this is one more vector. So you have A and B both. How do you write the equation? R is equal to A plus lambda times B vector. Right? This is what we learned. R equal to A plus lambda times B vector, because lambda times B vector is any vector parallel to the line. R is your position vector of the given point. So we'll take this as given point. We took this one, anyone, take anyone as given point. plus lambda times b vector will be any vector perpendicular to this, will be 3 minus 3 minus 2 minus minus 2 and 6 minus minus 5. So that's over here, correct? And in the Cartesian form, take any one as the given point. Any one as the given point. Suppose if we take this one as the given point, right? This one as the given point. So x minus x1 divided by direction ratio. What will be the direction ratio? 3 minus 3, that means 0. Equal to y minus minus 2, that means y plus 2 divided by direction ratio. Minus 2 minus minus 2, that means minus 2 plus 2, again 0. Is equal to z minus minus 5, that means z plus 5 divided by 6 minus minus 5, that means 11. Z plus 5 divided by 11. That's how you can write the Cartesian form also without any trouble, without any problem. We need one shot for all the syllabus also. Just let the boards get over, bacha. Tarun, just let the just till tomorrow. After that, we are again starting with our 2026 series. PYQs and everything we'll be doing. Just 4 or 5 days or some 6-7 days we have dedicated only for the board students because we really wanted to help them. Angles between two lines is the angle between the vector parallel to them, and we know how to find the angle between two vectors. A dot b cos theta, right? Cos theta is equals to A dot b divided by magnitude of A into magnitude of B. So we'll just find the angle between the vectors parallel to them, and that's how we'll be able to find the angle between the lines. Assuming a point on the line, assume any point, right? Put many times we'll do this with questions. For example, here we have to assume a point. Okay. So what we'll do, we'll suppose for on this line we want to assume a point, right? We can write the equation very easily. X minus x1 divided by A equal to y minus y1 divided by B, z minus z1 divided by C. We'll put all of them equal to some constant k. So any point on this line, x will be equal to k times A plus x1. So x will be equal to k times A plus x1, correct? Y will be equal to k times B plus y1, and z will be equal to k times C plus z1. We can simply assume like this. Any point we can assume like this. Now when to do that, I'll show you. General point on line. For example, on this line I want to take a general point, so I'll take x minus 1 divided by 1 equal to y minus 2 divided by minus 1 is equal to z minus 3 divided by 2 equal to some k. So any point if I want to take, that will be equal to k plus 1 comma minus k plus 2, that means 2 minus k and 2k plus 3. So this will be any point assumed on this line. There is locus in maths. My focus is on you. Wow, king of tears. You are full of shairi, bro. That too in English. Amazing. Amazing, bro. Okay. Show that 3 lines with direction cosine, these are mutually perpendicular. Right? If suppose 2 lines are there which are mutually perpendicular, whose direction cosines are given to you. Right? So direction cosines means A1 I cap plus suppose plus B1 J cap plus C1 K cap. This is one line. And A2 I cap plus B2 J cap plus C2 K cap. This is some other line. So if they are perpendicular, then your A1 A2 plus B1 B2 plus C1 C2. This will come out to be equal to 0. Just remember this much. If these 2 lines are perpendicular, then this will be equal to 0. What are A1 B1 C1? Direction cosine, or call them direction ratios, anything. Right? Direction ratios are just multiples of direction cosines. This one A2 B2 C2 are direction cosines of line 2. So simply we'll just check 12 divided by 13 multiplied with 4 by 13 plus minus 3 by 13 multiplied with 12 by 13 plus minus 4 by 13 multiplied with 3 by 13. Is this coming equal to 0? Sir, yes. 12 3s are 30, minus 36, 48 minus 36 and minus 48 minus 36 minus 12. Minus 36 minus 12 minus 48. 48 minus 48. Array, this is coming equal to 0. That means these 2 are mutually perpendicular. Some product of these 2, 4 into 3, 12. 12 into 4, 40 minus 48. 3 into 12, 36. 36 plus 12, 48. 48 minus 48, 0. These two product is also coming mutually. 4 by 13 into 3 by 13 plus 12 by 13 into minus 4 by 13 plus 3 by 13 into 12 by 13. If this is coming equal to 0, this sum is coming equal to 0, that means they are mutually perpendicular simply. Okay. Show that the line through the points is perpendicular to the line through the points. This also you can do. Line through these 2 points. How will you write the line through these 2 points? How will you write? Take this as assumed point. Let's say I am writing in vector form. So x minus 1, right, divided by direction ratio. What will be the direction ratio? How will you find the direction ratio? 3 minus 1, that means 2. This is how you will find the direction ratio, no? Vector parallel to these lines. So take one as assumed point. Suppose if I am taking as assumed point, I am taking this as point on, both the points are on line, but let's say this point is on the line. So x minus 1 divided by 3 minus 1, 2 equal to y minus 1, that means y plus 1 divided by 4 minus 1, that means 5 equal to x minus z minus 2 divided by minus 2, that means minus 2. This is this line. Okay. Similarly, this line will become what? X minus 0 divided by 3 minus 0, that means 3 is equal to y minus 3 divided by 5 minus 3, that means 2 equals to z minus 2 divided by 6 minus 2, that means 4. Now, if these two are perpendicular, that means direction ratios product should add up to 0. That means 2 into 3 plus 5 into 2 plus minus 4 into 4. This should add up to 0. And yes, 6 plus 10, 16 minus 16 will equal to 0. That's how we can show that these are mutually perpendicular, or lines passing through these points and these points are perpendicular to each other. Alright, show that the line passing through are parallel. This same way we can show parallel also. X minus 4 divided by 2 minus 4 minus 2 equal to y minus 7 divided by 3 minus 7 minus 4 equal to z minus 8 divided by 4 minus 8, that means minus 4. Correct? This will be the line. And for these 2 points, x plus 1, x minus minus 1, that means x plus 1 divided by 1 minus minus 1, that means 2 equal to z minus minus 2, that means z plus 2 divided by, what is the equation? X minus x1 by direction ratio. So z plus 2 divided by 2 minus minus 2, that means 4 equal to equal to z minus 1 divided by 5 minus 1, that means 4. X minus 1, x plus 1 divided by 1 minus minus 1, 2. Yeah, minus 2, minus 4, minus 4. If we multiply all the 3 with by direction ratios of this and direction ratios of this are proportional. We'll say drs of this line and drs of this line are proportional. Minus 2 by 2 is equal to minus 4 by 4 is equal to minus 4 by 4. They are proportional. That means we can simply say that the line which passes through these 2 points and these 2 points are parallel to each other. This is how you will show. Write the Cartesian form equation, and this is how you can easily show. Find the equation of line which passes through point this and parallel to this vector. Equation of this line which passes through this point and parallel to this vector. But if it is passing through this point, how do we write? R is equal to A plus lambda B. What is A? Given point on the line. This is any general point on the line. Correct? That's what we do. So this will become, this is the position vector of given point on the line. Given point is this. That means I cap plus 2j cap plus 3k cap plus lambda times B vector. That means parallel to this line. B vector is this given to us. So 3I cap plus 2j cap minus 2k cap. This will be the equation of R. R will become what? I plus 3 lambda I cap plus 2 plus 2 lambda j cap plus 3 minus 2 lambda k. This will be the equation of line in the vector form. This is the vector form. And if you want to write the Cartesian form, assumed point will be this x minus 1 divided by direction ratio of line parallel. Direction ratio will be 3 of x. Y minus 2 divided by 2 equal to z minus minus 2, sorry, z minus 3 divided by minus 2. This will be the Cartesian form. Both the forms you can write whenever you want. Very simple. Simple way. Very simple way you can write this. Find the equation of line in vector and Cartesian form that passes through this point. Passes through the point with position vector, positive vector means position vector, 2i cap, j cap, 4k cap, and its direction is this. Direction means vector parallel to this line. Direction of line means, direction means what? This is the vector parallel to this line. Okay, so simple. R vector is equal to A vector plus lambda times B vector. Right? R vector, we want to know what is R vector. Okay. Right? Vector form, if we want to write, try writing once on your own. I'll just take a minute. Just now we did know. Find the equation of line in vector and Cartesian form. Position vector, this A is given to us. 2i cap minus j cap plus 4k cap is given to us. Plus lambda times vector parallel to this line is also given to us. I cap plus 2 j cap minus k cap. Both the things are given to us. So our vector form will become 2 plus lambda I cap minus 1 plus 2 lambda j cap plus minus 1 plus 2 lambda j cap plus 4 minus lambda k cap. This is the vector form. Cartesian form also you know. Cartesian form also new. This is the position vector. So 2, 1 and 4. 2 minus 1 and 4 will be the points. 2 minus 1 and 4 will become the point. So x minus 2 divided by direction ratio of I cap. So 1 equal to y minus minus 1, that means y plus 1 divided by direction ratio, that is 2. Z minus 4 divided by direction ratio, that is minus 1. This is how this is going to be. Both the forms you can simply write for as many lines as you want. Pushpa sir, please make a video on all complete concepts of all chapters. Video, beta video will be too long for that. How will I upload that? We can take live if you want. Right. For example, this type of question comes. Cartesian equation of given. Cartesian equation is given. Write its vector form. So position vector will become what? X minus x1. What is the general form? X minus x1 divided by A equal to y minus y1 divided by B is equal to z minus z1 divided by C. This is the general Cartesian form in which x1, y1 and z1 are the position vectors, are the components of the position vector of any general point on the line, of the given point on the line which is given to us, 5, 4 and 6. So this will become, x1 will become equal to 5, y1 will become equal to minus 4, x1 minus 4, it will become minus 4, and z will become equal to minus 6. So your A vector will become what? 5 I cap minus 4 j cap minus 6 k cap. This will be positive 6, positive 6 plus 6 k cap. This will be A. What will be B vector? B vector, that means vector parallel to this line. We'll use direction ratios. It will become 3 I cap plus 7 j cap plus 2 k cap. This will be the parallel vector. So your Cartesian equation is given, vector form we want to write. So R will be A plus lambda times B. That's what you have to do again. This is how you can solve. You can convert one equation to another, both the questions, right? Now, these type of question. Angle between the two lines. Angle between this line and this line. Angle between two lines is the angle between the vectors or lines parallel to them. Angle between two lines is the angle between the vectors parallel to these lines. Which vectors are parallel to this line? For this line, vector parallel is 3 I cap plus 2 j cap plus 6 k cap. And for this line, vector parallel is I cap plus 2 j cap plus 2 k cap. This is the vector parallel. So angle between these two vectors will be, angle between two vectors is what? Just now in vectors we learned this. This will be cos theta. So cos theta will come out to be equal to dot product of these. That means 3 plus 4 plus 12. 3 plus 4 plus 12. 3 into 1 plus 2 into 2 plus 6 into 2 divided by mod of this, sorry, magnitude of this, that means 9 plus 4 plus 36, 45 plus 4, 49, square root 49, and here square root of 1 plus 4 plus 4, 8 plus 1, 9, right? So this will become 16 plus 3, 18, 16 plus 3, 19, divided by 7 into 3, 21, 19 by 21 will be the angle. So theta will be equal to cos inverse of 19 by 21. Same way you can do with these two also. Yes, sir. You can take a short life for concepts. Yes, I'll try that. Okay. A short life for all the concepts. Last minute revision, we can do that. Okay. So these are your important concepts. Here also you can do the same thing. Angle between these two lines. So these are direction ratios. So you have, for suppose in between these two lines you want to find. So vector parallel to this line will become 2 I cap plus 5 j cap minus 3 k cap, and vector parallel to this line will become minus I cap plus 8 j cap plus 4 k cap. Correct. And if you want to find the angle between these two, then this multiplied with this, that means angle between these two, that means again dot of this divided by magnitude of this. So dot of this will become 2 minus 1 minus 2 plus 5, 8, 40 minus 12 divided by magnitude of this one will be 4 plus 25 plus 9, 28, and magnitude of this will be 1 plus 64 plus 16. So 64 plus 15, 79. That's it. This will be the angle. Cos theta will be equal to this. That's it. So very simple. 3D is not difficult at all. 3D is not difficult at all, guys. One more type of question I want to tell you. Find the distance between this particular type of question. This can be asked, right? Because now find the distance between a point and this line. Suppose this is your line and this is your point, that means minus 2, 4, minus 5. Suppose this is the point and you are finding the distance between this point and this line. This line is your x plus 3 by 3 equal to y minus 4 by 5 equal to z plus 8 by 6. Okay, this is your line. Now what you'll have to do, you'll have to assume any point on this line. Suppose if we want to assume this point on this line, how do you assume a point? We'll put this equal to k. So this point will become 3k minus 3, comma 5k plus 4, comma 6k minus 8. Okay, this point can be assumed. Now this line and this line are perpendicular to each other. So what will be the, if I want to write the vector form of this line, if I want to write the vector form of this line or just vector parallel to this line, if I simply want to write a vector which is parallel to this line, what will be that vector? 3k minus 3 minus minus 2, that means plus 2 I cap, 5k plus 4 minus 4, that means, so minus 3 plus 2, direct only, minus 3 plus 2 minus 1, 3k minus 1 I cap, 5k plus 4 minus 4, that means plus 5k j cap, plus 6k minus 8 minus 5, minus 8 plus 5, 6k minus 3 plus 6k minus 3 j cap will become the vector parallel to this line. And vector parallel to this line I already know. Vector parallel to this line is simply 3 I cap plus 5 j cap plus 6 k cap. Okay, or simply, if not vector only, direction ratios of this line and direction ratios of this line, right? So if I simply want to know the direction ratios of these two lines, drs of this line What are the DRs of this line? 3k minus 1, comma 5k, comma 6k minus 3. Correct. DRs of this line is already given to me 3, 5, 6. So I just make the product of DRs, sum of product of DRs equal to 0. Find the value of k. I can simply find this point and then I can find the distance with distance formula. This is how you are supposed to do. What will I do? I'll make the product 3k minus 1 into 3, 3k minus 1 into 3 plus 5k into 5, that means 25k, plus 6k minus 3 into 6 plus 6k minus 3 into 6 equal to 0, because they are perpendicular. This and this are perpendicular, so sum of product of direction ratios will be equal to 0. If this is equal to 0, I'll get the value of k. If I got the value of k, I'll get this point. Then I can find this distance. This is not given in examples in your NCERT. In miscellaneous, one similar question is there, but this can be asked in your boards also. This usually comes in mains, but this is considered as an easy question. Now, shortest distance between two lines. Simple thing. Shortest distance between two lines. How do you do that? Shortest distance between skew lines or parallel lines. Skew lines means they are not intersecting, but they are not parallel also. Now this is 3D. One line is here, one line is here, right? One line is here and one line is here. These are not intersecting, but these are not parallel also. So non-parallel lines in a 3D plane are called skew lines, and parallel lines in a 3D plane, that means their vector parallel to them is same. A1 plus lambda b, A2 plus mu b. Vector parallel to them is same. That means these two lines are parallel. If two lines are parallel, then the distance between them will be b, that means parallel vector, cross with A2 minus A1 divided by magnitude of b and mod of this. That will be the distance. The mod of this means magnitude of this entire thing. Remember and write these formulas down. Okay, between skew lines, simply b1 cross b2, b1 cross b2, because these are not parallel, so b1 and b2 are different. b1 cross b2 dot with a2 minus a1, dot b1 cross b2, then dot it with a2 minus a1, divide by magnitude of b1 cross b2 and find the magnitude of entire thing. These are the simple formula. Only two questions are there in your NCERT regarding them. Suppose if in Cartesian form you have the lines. Suppose you have the line in Cartesian forms, right? Then this is how you find the distance between them. Suppose you are directly given in Cartesian form, then simply find the distance between them like this. Suppose you have two lines, x minus x1 divided by a1 equal to y minus y1 divided by b1 equal to z minus z1 divided by c1, right? And one more line is there, which is x minus x2 divided by a2 equal to y minus y2 divided by b2 equal to z minus z2 divided by c2. Then distance between them, shortest distance between them can be found like this. Shortest distance between them can be found like this: x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. Determinant of this, you'll have to find determinant of this. This is determinant. Square root of, just take difference of couple squares, that means b c1 b1 c2 minus b2 c1 whole square, c1 a2 minus c2 a1 whole square plus a1 b2 minus a2 b1 whole square. You can change the order also, order won't matter. ab bc ca, just remember that. AB, BC, C. You can easily remember this formula also without any trouble. Okay, don't forget that. For example, find the shortest distance between these two lines. First check, are the lines parallel? I, J, K, 1 minus 1, 1. And here 2, 1, 2. Not proportional, that means they are not parallel. So what will we do? We'll simply find the distance by formula which is known to us. That means A2 minus A1. This is A2, this is A1. Right? A2 minus A1 we'll do first. Dot it with b1 cross b2, right? Which are this is your a1, this is your a2, this is your b1, this is your b2, correct? And this divided by mod of b1 cross b2. Mod of b1 cross b2 also you'll have to divide it with. Remember this much. Okay. Now suppose B1 cross B2. How will we do B1 cross B2? B1 cross B2 first we'll find. How did we learn to find B1 cross B2? Determinant I, J, K. Components 1 minus 1, 1. 1 minus 1, 1. 2, 1, 2. 2, 1, 2. This will be our B1 cross B2. That means I cap multiplied with minus 2 minus 1. That means minus 3. Minus 2 minus 1. Minus J cap multiplied with 2 minus 2. 2 minus 2 that means 0. Plus K cap multiplied with 1 minus minus 2. That means 1 plus 2. So 3. So it will become minus 3 I cap plus 3 K cap. This will be your B1 cross B2. Now do A2 minus A1. What will become your A2 minus A1? A2 minus A1 also we can simply do 2 minus 1. That means 1 I cap. Then minus 1 minus 2. That means minus 3 J cap. Correct? Minus 1 minus 1. That means minus 2 K cap. Okay. That will be A2 minus A1. And what will be sorry, this is not mod of B1 cross B2. This is just B1 cross B2. And your mod of B1 cross B2 will become magnitude of this. That means 3 square plus 3 square, 9 plus 9, that means 18, square root 18. This will be square root. Okay. So this entire thing will become I cap minus 3 J cap minus 2 K cap dot with minus 3 I cap plus 3 K cap divided by magnitude, that means square root 18. So this dot product also will come scalar only. 1 minus 3 minus 3 minus 3 0 minus 3 and minus 2 into 3 minus 6 minus 3 minus 6, that means minus 18. Minus 18 by root 18 is your distance. But because this is a distance, will minus 18 divided by 18 will be equal to 18 divided by root 18. Okay. This is how you can find the distance. Distance between parallel lines usually doesn't come, but still you remember the formula A2 minus A1 dot with B, because B is same. B1, B2 are not two different things. B is same now. A2 minus A1 dot with B divided by magnitude of B. Simple formula. This one, right? Divided by magnitude of B. If they are parallel, how will you check? Check the direction ratios. All right. For example, in this case also they are not parallel. Now this is Cartesian form. So simply x2, this formula will use x2 minus x1. That means what is this x2? Minus 3 minus 1. Right? Minus 3 minus 1. Minus 3 minus 1. Minus 5 minus 1. What is, oh sorry. First write x1, x2 separately. So x1 over here is equal to minus 1, because x minus x1 is the form. What is x2 or what is y1? Y1 is also minus 1. What is z1? Z1 is also minus 1. Similarly, x2. What is x2? 3. Y2 is 5. Z2 is 7. Now apply the formula. Right? Now apply the formula. 3 minus 1, that x2 minus x1. Now you can apply this formula. Right? And I'll write the values of ABC also. So A1, B1 and C1. A1 is 7, B1 is minus 6, C1 is 1. Similarly, A2 is equal to 1, B2 is equal to minus 2 and C2 is equal to 1. Which formula you will apply? This one, x2 minus x1, y2 minus y1, z2 minus z1. Right? Here A1, A2, A1, B1, C1, A2, B2, C2. You will find the determinant of this. Divide it with what? Square root of A1 B2 minus B2 A1 whole square plus B1 C2 minus C2 B1 whole square plus A1 C2 minus C2 A1 whole square. Just apply this entire thing. It will be calculative but easy to remember formula. Sir, audio is very low. Ashwin, even now? Yeah, I tried everything. Actually, there is no support today. Everybody left. It's already high time. Everybody, all the support team has left already. So that is why I'm not able to Let me check once again. I'll try to speak with keeping the mic close so that you can hear as much as possible. Shortest distance between these two lines. So how will you, if these type of lines come, what is this actually? I cap minus 2 j cap minus 2 t k cap, correct? Minus 2 t k cap, sorry, minus 3 k cap, sorry. I can write like this, minus 3 k cap. So what is this line? 1 minus t I cap is written, plus t minus 2 j cap is written, plus 3 minus 2 t k cap is written. Okay, so this can be written as I cap minus 2 j cap plus 3 k cap plus t times minus I cap minus 2 minus I cap plus j cap and minus 2 k cap. I can write like this. So t will become that constant. Instead of lambda there is t. So now a is this and b is this. In this case you can do like this also. Sir, it's in your hand, it's fine. If it's in your hand, it's fine. Thank you. Now let's come to our last thing of the day, which is linear programming. Okay, linear programming, LPP. Linear programming we'll revise. Linear programming is an very easy stuff. There is no problem with that. What does it say actually? I'll tell you. For example, we have linear equation. Generally we have linear equation. Let's say 2x plus 3y is equal to 12. Instead of equal to, suppose I do less than equal to 12. Linear inequality will be there, right? Now if I want to plot it on an xy plane, how will I plot? I'll just plot 2x plus 3y equal to 12. This line I'll plot. First I'll plot this line. So how will I plot? X0, y is equal to 4. When x is 0, y is equal to 4. So 0, 4, let's say. And when y is 0, x is equal to 6. When y is 0 on x-axis. And x is equal to 6. X will be equal to 6. So let's say this is 6, 0. So how will I plot this line? This line will be plotted simply like this. I'll connect these 2 points and this line is plotted. Alright, this is how it will be plotted. Now it's telling me that 2x plus 3y should be less than equal to 12. Less than means this inequality means all the area which is coming below this line. This inequality means all the area which is coming below this line. Alright. Now suppose I take one more restriction, that my x should be greater than equal to 0 and y should be also greater than equal to 0. In that case, my area x and y both should be equal to greater than 0. Then that will mean this area, only positive, first quadrant. Right, so 3 restrictions suppose. So this means this particular area. Linear programming talks about these type of problems which we solve graphically. Now suppose I have one more restriction. Suppose I want my x plus y should be equal to 4. Suppose I want that my x plus y should be greater than equal to 4. Okay. If I want my x plus y should be greater than equal to 4, I'll again plot x plus y equal to 4. X is 0, y is 4. When x is 0, y is 4. So that means this point. When y is 0, x is 4. That means somewhere over here. So 4, 0. So if I plot this line also, what will I get? What will I get? I'll get this line. Right? I'll get this line. Now I want area which is greater than x plus y greater than 4. So which area will coincide over here? I'll color this with let's say this color. So this area will come, right? The area which is below this line, which is 2x plus 3y equal to 12, and which is above this line, which is x plus y equal to 4, above this line. So this area, and x plus y, x and y both are still positive. So this is my area which I want. This is the area which will satisfy all the four conditions. This is what linear programming problems talk about. Now, according to this, only some. Now, suppose here instead of greater than equal to, I just have greater than. Suppose I only have greater than over here. Only greater than is over there. In that case, this line, which is representing x plus y equal to 4, will just get dotted line. I'll just make it a bit dotted line. How will I rub it? You cannot rub it, no? So, don't come like that. So instead of this line, what will I do? I'll make a dotted line. Let's say I'll just make a dotted line. Dotted line means I'm not including this line. X plus y greater than 4, but not including the points on this line. So I'll just make this line as dotted line above axis. Very good. Okay, now some definitions related to it. Objective function. Objective function, that means a linear function which will be of this form, right? Which will be given of this form, where a and b are the constant and which has minimized. Now, what they'll ask you one question. Along with this, they'll also ask you to maximize or minimize something. Some function will be given to you, let's say 400x plus 300y. You want to maximize this with respect to these conditions. So this will be called as your optimizing function. Objective function. Constraints, all those four things: x greater than 4, y greater than 4, 3x plus y greater than 4, x plus y greater than 4. All these are constraints, right? All the linear inequalities given to you will be called as constraints. Optimization problem. Optimization problem, that means maximize or minimize this. They'll ask you to optimize the objective function. They'll ask you maximize the objective function or minimize the objective function. So that function, that problem of maximizing and minimizing will be called as optimizing problem. Feasible region, applying all the constraints, whichever region is common according to all the constraints, that will be called as your feasible region. Simple definitions, because sometimes CBSE asks questions on definitions also. Feasible solutions. So feasible solution will be the boundary points. For example, over here in this one, if we talk about the boundary points, this is a boundary point, this is a boundary point, this is a boundary point. 3 boundary points we are getting which are enclosing this area. So these are going to be your feasible solutions. These are going to be your feasible solution. The boundary points of the enclosed area will be called as your feasible solutions. Optimal or feasible solution. Whichever is maximum, or if they are asking you to maximize, then maximum will be the optimal feasible solution. If they are asking you to minimize the optimal function, then that minimum value will be the optimal feasible solution. We'll understand these things with problems. Okay. For example, general question. This question last year they asked. A linear programming problem deals with optimization of linear, logarithmic, quadratic, exponential function. Obviously, linear function. We cannot have quadratic function in that. Simple question. Only linear function will be using there. Number of corner points of feasible region determined by constraint. Okay. What are the constraints? X greater than 0, y greater than equal to 0. That means this is your first quadrant. Then x plus y greater than equal to 4. So you will plot x plus y equal to 4. 0, 4 and 4, 0. Correct? Greater than equal to. Greater than equal to. So that will give you. This line extended there and extended there. This line, right? But first quadrant. So which will be your feasible region? This will be your feasible region. This will become your feasible region. This will become your feasible region. Number of corner points of feasible region. This point is corner, this point is corner, this point is corner point. Right? So 3 corner points you are getting for the feasible region. But no. Not. Something wrong here. Wait. x plus y is greater than 4. Greater than 4, that means region above this line. This is your feasible region. This is your feasible region only in first quadrant. Only in first quadrant, this is your feasible region. So if feasible region is open, we cannot have any boundary points in the feasible region, right? We'll have only boundary points over the line, over here. Only 2 boundary points will be there. 2 will be the correct answer, not 3, right? So check, plot it properly. X plus y greater than 4, that means all the points above this line. So these are the points above this line. X and y greater than 0, that means first quadrant. All the points in first quadrant which are open. Right? So only 2 boundary points we can have. We cannot have any boundary points in the infinity. So 2 was the correct answer. This was also asked last year only. Solve the following linear programming problem graphically and maximize this. Suppose you want to solve this linear programming problem graphically, and then we have to maximizing this, and constraints are also given to us. Okay, constraints are also given to us. Let's do that. X plus 2y less than equal to 12. Let's write the constraints first. So how to do this? First constraint is x plus 2y less than equal to 12. Just understand the problems in this chapter, you'll be able to understand, not difficult. Only one exercise is there in your NCERT. 2x plus y less than equal to 12. Second is 2x plus y less than equal to 12. Right. Third is 4x plus 5y greater than equal to 20. Here we have 4x plus 5y greater than equal to 20. Okay. One more we have x greater than equal to 0, y greater than equal to 0. X greater than equal to 0, y greater than equal to 0. Check greater than equal to and all also. Dotted line or solid line. Which line you have to make. Okay. So what we'll do, we'll plot first. Okay. So let's say we are plotting like this. Alright. So x plus 2y equal to 12 first we'll plot. First we'll plot x plus 2y equal to 12. So x is equal to 0, then y will be equal to 6. So 0, 6 let's say, right? Y equal to 0, then x will be equal to 12. So let's say 12, 0 is this. We'll plot this line. So it will come somewhat like this. Okay. Now this is my line x plus this is my line x plus 2y equal to 12. Which region I want? I want the upper region. First let's plot all the lines. So 2x plus y equal to 12. X is equal to 0, y is equal to 12. So I'll take this a little above, and let's say 0, 12 is over here. Right? And y is equal to 0, x will be equal to 6. So let's say 6, 0 is over here. So if I plot this line will come. This line will come like this, and solid line because solid line, right? Because greater than equal to is there, or smaller than equal to is there. Now 4x plus 5y equal to 0. When x is 0, y will be equal to 4. When x is 0, y will be equal to 4. So 0, 4, let's say somewhere over here. And when y is 0, x will be equal to 5. So 5, 0, let's say somewhere over here. Now this line, if I'm plotting, it will be like this. Okay. Now what is my condition? I want x plus 2y less than 12. X plus 2y, so this was my x, lines are getting confused. 2x plus y equal to 12. This is my 2x plus y equal to 12. And this line which I just now made is 4x plus 5y equal to 20. So plot carefully. Now I want x plus 2y less than equal to 12. X plus 2y equal to 12 below this entire area, which is x plus 2y equal to 12. This is x plus 2y equal to 12. So this area below this, correct? Area below this, area below this line. I'll shade all three with 3 different colors. Let's say. So let's say this is my x plus 2y equal to 12, right? And okay, 2x plus y equal to 12 is this line. 2x plus y equal to 12 is my this line. This is this line. 4x plus 5y is some other line, which is this one. This is 4x plus 5y. Now, which will be my feasible area? I want area below this line. I want area below the red line. So below the red line and below 2x plus y also. Below this also. I want below this, below red line and below blue line. But I want above the pink line and in the first quadrant. So this will become my feasible area. In the first quadrant only I want. Right. Now I'll mark the boundary points. Now what I'll do, I'll mark the boundary point. This is a boundary point, 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 and this is a boundary point. Now this boundary point I know, this is 0, 4, this is 0, 6, this is 5, 0, this is 6, 0. What about this boundary point? This is the intersection of 2x plus y equal to 12 and x plus 2y equal to 12. So 4, 4. This will be 4, 4. When you solve these two lines, this point will also come. So 4 boundary points we have. Right? We'll simply we have 4 boundary points. We simply understood that we are going to have 4 boundary points. So x, y. Okay, what are the 4 boundary points? 5 boundary points. Right? So 0, 6 is one boundary point. 0, 4 is one boundary point. 5, 0 is our boundary point. And 6, 0 is also our boundary point. As well as 4, 4 is also our boundary point. Now, what was our problem? What was our optimization problem? We had to optimize this 500x plus 300y. We want to optimize this 500x plus 300y. This was our optimization function. Now, we'll check at all these points. 0, 6, x0, y6, 1800. x0, y4, 1200. x5, y0, 2500. x6, y0, 3000. 6 into 5, 30, 3000. 4, 4. So this will become 2000 and this will become 12,000. 12,000 plus 2000. 4, 3, 12. This will be 1200 and this will be 2000. 2000 plus 1200, 3200. 3200. So your maximum value, maximizing this, maximum of z will be equal to 3200. That's it. You solve the linear programming problem. That's it. This is how we maximize. Check on all the boundary points. On all the boundary points, which one is giving you the maximum value of the optimizing function? Okay, so 3200 becomes your maximum of z. Simple, as simple as that. Now let's go ahead. This question came in 2021. All right, the corner points of the feasible region determined by the system of linear equation are as shown below. This is the corner point 0, 2. This was given as a corner point 0, 2. This was given 3, 4. This was given 5, 2. And this was given as 4, 0. These are the corner points. And 0, 0, obviously. This will also be a corner point. This was not mentioned, but this is there. Okay. Now, let z be a function. Z is given as a function. There is a function given to us, z, which is given as 13x minus 15y. Be the objective function. Find the maximum and minimum values of z and also the corresponding points at which maximum minimum values occur. So we'll check at all of them. 0 plus minus 15 into 2. So minus 30. On 0, 2, what we'll get? 0, 2, 0 minus 30. So minus 30 will be the value. On 3, 4, we'll check. 39 minus 60. Minus 21. On this we are getting minus 21. On 5, 2 we'll check. On all these points we'll check and we'll tell on which one minimum is coming. That will be the minimum value. Let z be kx plus y be the objective function. Find k if value of z at this point is same as the value of z at b. Suppose in second part it is, so this you must have understood, right? Whichever gives us the maximum, we'll write that. Simply we'll check on all the points. We'll check the value of this function on all the points and then we'll find minimum and maximum and we can simply tell the answer. Okay. So all the boundary points will check 5, 2, 4, 0. On all these boundary points will check 0, 0. Obviously, it will be not 0, 0 can be maximum. 0, 0 can also give you maximum because 0 is greater than negative values. Okay. So check on all these. Check also on 0, 0. Now, next thing in the next part, it is saying that let's say z is a function which is kx plus y, right? And it is asking you to find k if the value of z at a, that means this point, is same as value of z at b, that means this point. That means it is simply saying that means 5k plus 2y is equal to 4k plus 0. So it will give you k is equal to 2y. 5k plus 2 is equal to 4k. 5k plus 2, y's value is 2, is equal to 4k. So it is simply telling you k is equal to minus 2. K's value will come out to be equal to minus 2. It's simple questions will come on linear programming. If you just understand the concept once, it will be clear for you. This question came in 2020. The corner points of feasible region determined by the system of linear inequalities are given. These are the corner points given. If the maximum value of z, right, occurs at both 2, 4 and 4, 0, then what is the meaning of that? By maximum value occurs at 2, 4 and 4, 0 both. That means value at 2, 4 and 4, 0 will be same. If it's maximum, there will be only one maximum. That means value will be same. So that means 2 times a plus 4 times b will be equal to 4 times a plus 0 times b. That means 0 will be equal. These two things will be equal. That means 2a will be equal to 4b. That means a will be equal to 2b. That means which will be your answer? Option A. This is how we can solve this simply and easily. Okay. Let's see some more. Sometimes what happens, your feasible area might come open. It might not be closed. For example, let's take this question, right? 2x plus y is greater than 8 equal to 8. X plus 2y is greater than equal to 10 and xy greater than equal to 0. So we'll plot very simply. Okay. 2x plus y greater than equal to 8. X is 0, then y is 8. So 0, 8, let's say over here. Y is 0, then x will be 4. So let's say 4, 0 is over here. X plus 2y. X is 0, y is 10. As x is 0, y will be 5. So 0, 5, let's say over here. 0, 5, let's say over here. Okay. Plot a little bit roughly, but yeah, it should look accurate. And if y is 0, x will be 10. So let's say 10, 0 is 4. So our lines will make very easily. Let me use this. Okay. This will be your which line? This is your 2x plus y equal to 8. Right. This is your x plus 2y equal to 10. And let's say another line which is 2x plus y equal to 8 will come on joining these. Right. And first quadrant we want. So here 2x plus y greater than 2x, it should be greater than 2x plus y. This line, that means this area, and it should be greater than this also. X plus 2y equal to 10, that means this. So which is your feasible region, which is common to both, which is common in both the conditions? Greater than this also, greater than this also. What will be your common area? The common area will be outer. That means this entire will be your this entire area, all this entire area, this become your feasible region. And this is open now. This region is now open. Correct? Obviously greater than this also, greater than this also, right? So this open area will be your feasible area. Now what to do when open area comes? Although this is very rare that you'll get open area, but what if it comes? So in this case, for example, we are getting open area, so we'll check the values. What we'll do, we'll check the values. Okay, x, y, corner points are 0, 8, 10, 0. So 0, 8 and 10, 0. We'll check at these two. 0, 8 for this function is giving us 56 and 10, 0 is giving us 50. Correct? So which one is maximum? 56. 0, 8 is 56 is maximum. This is maximum. But because this area is open, we'll check once whether our 5x plus 7y, what we'll do, we'll take this function and we'll keep it greater than 56. We'll check that can this function be even greater than maximum value. We'll check that, right? Can it be greater than maximum value? We'll check that. So we'll put 56 over here. Now we'll plot this. When x is 0, y will be 8. When x is 0, y will be 8. So 8, x is 0, y will be 8. So this point only. And when y is 0, x will be 56 by, so 11 point something. So it will come somewhere over here. Now when we are plotting this, let's say I'm plotting this with white line only. So when we are plotting this region is coming. This is what we are getting. Okay, this is what we are getting. Now this is this is also coinciding the area which we are which is common to us. So yes, this can come. This can contradict our fact that we have nothing common over here. What does this mean? Just give me a minute. Actually, we have plotted wrong. Yeah, we connected 0, 8 with 10, 0. The plotting will be different. Wait just a minute. I'll connect it. Let me plot like this. This is your this line and this is your this line. Right? Still you're optimizing area. Your feasible region is coming open only, but with 3 boundary points. There will be 3 boundary points. There are going to be 3 boundary points. The intersection of these 2 lines also we'll have to find, which will come as 2, 4. Yeah, 2, 4. This point will be 2, 4. So we'll have to check at 2, 4 also. 2, 4. 5 into 2, 10, 7 4s are 28. 28 plus 10, 38. So maximum is coming as 56. But when we are plotting this line, now what was this giving us? This line was coming as over here. Right? This line was coming over here, which is in our feasible region. This line when we plot, it is in our feasible region. Suppose if it was not in our feasible region, then no problem. If this line was not in our feasible region, then it was no problem. Right? If it was not in our feasible region, then there was no problem. But this line is in our feasible region. That means there can be some value which is greater than 56. Then we'll say it cannot be. We'll simply say that feasible region coincides with this line, with this inequality. That why it is not possible to find maximum value. We'll simply write it is not possible to find maximum, to maximize or to find maximum value. Or there is no maximum. Anything. There is no maximum. Now suppose instead of maximizing, they asked us to find minimize. Could we minimize? We'll check that also. So minimum value occurs at 38, for example. So what we'll do, same inequality, we'll check with 38. We'll put this optimization function less than 38. What we'll do, we'll check with less than 38. Now check, x is equal to 0 gives you 5 point something. So it will occur somewhere over here, right? Y is equal to 0 gives you 7 point something. So it will occur somewhere over here. Now when we are plotting these 2 points, this line is being formed, which is not coinciding with our feasible region. What was our feasible region? This was our feasible region. This red area was our feasible region, outer region. This is not coinciding with our feasible region. That means 38 can be the minimum value, but maximum value we cannot find only. The maximum value we cannot find. Let's see some more questions. So this is the only question which can become a problem for you, but it is rarely chances are there that this case will come, that it is not possible to find the maximum of this function. The solution set of inequations 3x plus 5y less than 7. By less than 7, not equal to is not there. 3x plus 5y less than 7, x0, y 7 by 3, 7 by 5 and y0, x. So less than 7 basically, less than 7, equal to is not there. So that means dotted line, if we are graphing it, then line will become dotted, right? When we'll plot 3x plus 5y equal to 7, that line will have to plot as dotted line, right? Because it is not covering the points on the line. Options are whole xy plane except the points lying on the line. 3x plus 5y. No, it will contain the points which are below the line, right? Because less than 7. Second option, whole xy plane along with the points lying on the line. No, obviously this is also wrong. This is also wrong. Both are wrong, right? Open half plane containing the origin except the points on the line. Open half plane containing the origin. Yes, containing the origin, because region below this line will come and this line will be in first quadrant. So open half plane which is containing the origin will come except the points on this line, except the points which are there on this line. This came in 2023. X plus 2y less than equal to 76. This line is your x plus 2y less than equal to 76, and 2x plus y equal to 104 is this line, right? Let's say this, I take another color over here. This is your 2x plus y equal to 104, x and y greater than 0. All right, which is the feasible region? Below green line and above red line. Sorry, red line is your, this is your red line and this one is green line. So below green line and above red line. No, this is wrong option. This is showing below green line and above red line. So wrong. This is showing below green line and above and below red line. Below green line and below red line. No, common area will be different, right? Below green line and below red line will be this area. Above green line and below red line. Above green line and below red line. Yes. So this will be the area. Above green line and below red line. This is correct, right? Above green line, above red line will be open area. So third option was correct. So very easy questions will come. Okay, don't worry. 1 marks will be very easy. If suppose if we have a case study, now it's about case study. Now what is this saying? Read it properly. Once try to read it properly. Read the entire problem properly. A dietitian has developed a special diet using 2 foods, P and Q, each packet containing 30 gram of food P and 12 of food P. Each packet containing 30 gram. Total is 30 gram. Each packet is containing of 30 gram of food P. Contains 12 units calcium and 4 units iron, 6 units cholesterol and 6 units of vitamin A. Each packet of the same quantity, 30 gram only, but of food Q contains 3 units calcium, 20 units iron, 4 units cholesterol and 3 units vitamin A. So diet requires 240 units. A diet requires at least 240 units of calcium, at least 460 units of iron and at most 300 units of cholesterol. how many packets of each food should be used to minimize the amount of vitamin A in diet? Minimize the amount of vitamin A in diet. So calcium, if we'll add P and Q, calcium will be 12. Let's say calcium is X packets, right? Calcium is X packets. So what will we have? 12X and 3Y. Because calcium in P is 12 units, right? Calcium in P is 12 units. And let's say we have X packets of P and Y packets of Q. So 12 into X plus 4 units, 3 units in packet Q plus 3Y, right? This will become 12X plus 3Y. This will be calcium. Similarly, iron. Iron will become how much? 4 units of iron is in P and 20 units of iron is in Q. So 4X plus 20Y. Now similarly for if we talk about this third thing, cholesterol. Cholesterol, if we are talking about, then 6 units of cholesterol is in packet P and this one 4 units of cholesterol is in packet Q, so 4Y. We are assuming we have X P packets and Y Q packets. Okay. Now in anything else contains cholesterol and vitamin A is also there. 6 vitamin A here and 3 vitamin A. 6X plus 3Y. Right? 6 packets, 6 units of vitamin A in P and 3 units of vitamin A in Q. Right? Now a diet requires at least 240 units of calcium. So this should be greater than equal to 240. Calcium should be greater than equal to 240. At least 460 units of iron. So this should be greater than equal to 460. At most 300 units of cholesterol. So this should be less than 300 units. Correct. How many packets of each food should be used to minimize the amount of vitamin A? And this becomes your optimization function. That's it. What is the minimum amount of vitamin A? So just solve it like a linear programming problem. This is your optimizing function. These are constraints. Simply. And obviously X and Y will be greater than 0. Something they'll eat, right? So X, Y greater than equal to 0. That we'll have to apply. Because number of packets has to be there. Something should be there. So X and Y both should be greater than or equal to 0. That means first quadrant. That becomes your problem. One case study came like this. A dietitian wishes to minimize the cost of diet involving 2 types of foods, food X and food Y in kgs, which are available at the rate of 16 kg and 200 per kg respectively. The feasible region satisfying the constraint is shown in figure 2. Feasible region is this one. This orange color is feasible region. Okay, this line I'll mark. This line is your X plus 2Y equal to 10, and there is a dotted line over here. This dotted line is 4X plus 5Y equal to 28. Okay, and this line is given to you as 3X plus Y equal to 8. Let's say. Okay, what is it asking? It's saying, okay, something is written. So what is it asking? Let's say, what is it asking? Identify and write all the constraints which determine the given feasible region in figure 2. Very easy. X plus Y greater than 0. X and Y greater than equal to 0 because first quadrant. Now it should be above this line. It should be above X plus 2Y. So X plus 2Y should be greater than equal to 10, the feasible region. Okay. And it should also be above this line. This line, or if this feasible region is above this line also. Correct? Correct? So that means 3X plus Y greater than equal to 8. These are the conditions. And above the dotted line also. It is also coming above the dotted line. It should be above this line and the dotted line. Dotted line's equation is 4X plus 5Y greater than equal to 28. So these are the constraints. That's it. Now, if the objective function is z is equal to 16x plus 20y, z is equal to 16x plus 20y, do we have that equation? No. Okay, if the optimization function is this and the values of x and y at which the cost is minimum, also find minimum cost assuming that the minimum cost is possible for the given unbounded region. So you'll find the corner points, all the corner points are there. This is corner point, this is corner point, find the intersection over here. Here also find, here also, this point is also given to you. This is 10, 0. This point is what? 0, 8. Right? This is intersection point. Intersection point must also be given. Yes, this is given as 2, 4. This point is given to you as 2, 4. So check at all these 3 points. And also check if for minimum value, because open area is coming. So just check once. Just keep the optimization function less than, just keep your optimization function less than the minimum value. Keep your optimization function less than the minimum value and then check your line is not coinciding in the open area. It won't. When you'll check that, this dotted line will come. When you'll check, no, when you'll keep it less than this dotted line will come and this area will be enclosing. So your maximum value at will come at one of these 3 points. You'll simply get the answer without any trouble. So this was all about linear programming. Okay, one more, I'll remind you of the 3 batches that we have: Nexus, Nimbus and Phoenix. Don't forget to enroll if you're 2025, 2026 or 2027 aspirant of JEE. These are wonderful batches with wonderful teachers. Don't forget to like the video and all the best for your exams. We'll come again live tomorrow with something important.